calling. So we are planning to call you by maximum by 15th of December. So we will be having the test during that time. So you learn by yourself what is the difference between Arc Studio, between Acme, between UML, between something else. Today Bhaiya will be telling. Then today I will be giving some assignment to do by yourself. Do by yourself, you will be given. Nothing, whether you will use Acme or LTSA or Arc Studio, that is choice is up to you, but you have to justify. I will be giving separate assignment to each one. इंगोले तुम्हारी क्या था इंगोले?
The job management portal.
Job management.
Yes.
Job management. Somo, have you heard the name of Indeed? Somo.
Indeed. Yes, sir.
Yes, sir. If I ask you to develop a portal for Indeed, a full-fledged software for Indeed, Ingole Bhaiya had done. Okay, so likewise, Indeed is the #1 leading job portal in the world. So likewise, I'll be giving to all the boys individually to develop some software by 15th of December. We will finish up maximum by maximum by 9th of December. Then 1 week full time I'll be giving 16th of December or something. You have to show me your talent, 100% workable software, workable, implementable. So Somu will submit for Indeed or somebody will submit for X, Y, Z. So I'll be assigning today after the class hour, I'll be assigning, I am now writing down to whom to give what, and at 11:45 I will tell who will do what, and you have to study on that, write down the SRS, try with first UML, then try with Acme, then try with LTSA, then start implementing the code. I'll do it at 11:45. So let us study first. LTSA, you have studied it along with Rapid. Rapid and UML, you have studied it, right? लोग पढ़े हैं ना इंगोले?
Yes, sir. Yes, sir.
हाँ. Debo Bhaiya has covered it along with Rapid and UML. So try to remember. Again, it will be told today in the lab. So how you can proceed with LTSA? Ingole Bhaiya will tell you stepwise. So now start. Ingole start.
Yes, sir.
Okay, start.
So till now we have completed Arc Studio and Acme Studio. So today we will start LTSA. So it is Label Transition State Analyzer. So how LTSA is different from our Arc Studio? So on the left hand side is for Arc Studio. So Arc Studio defines basic structural modeling of prospective architecture. So here in Arc Studio we have component connectors, interfaces, links, general groups, as well as types of components, connectors, and interfaces. As we have seen, we have different components. We have used different connector types, stream connector, procedure call connectors, although eight types of connectors. So in Arc Studio, we have all those structural modeling and structural modeling of prospective architectures. So in LTSA, it is a tool for analyzing and simultaneously visualizing concurrent systems. So this word is important, concurrent. So it is for visualizing concurrent systems behavior using a modeling language called FSP. So this FSP is a finite state process. So in LTSA, what we will draw some a model for a system, and then we will check it. We will analyze it for concurrent systems. And the modeling language we will use it FSP is finite state process. And in Arc Studio is based on the highly extensible XCDL architecture description language. As we have seen before that in Arc Studio, we will draw the component, connectors, everything, and in the background, the language will be XCDL, architecture description language. So it will automatically generate the XML file as we have seen in the Arc Studio. We will just draw the component, the architecture of our software, and we will automatically generate the architecture description language. And in LTSA, models in LTSA are described textually as finite state process. So here we will draw FSP. By using FSP, we will draw our models. We will see how we can draw our models in FSP. So this is similar to our in BTech we had one subject theory of computation. So there we learn this FSP, finite state automata. Same thing we will see here. So the next is models. So what is a model? A model is a simplified representation of the real world. So here we will talking about models only in LTSA. We will draw different types of models. So the basic definition of a model is a simplified representation of the real world. So engineers use model to gain confidence in the adequacy and validity of a proposed designs. So to gain the confidence in our proposed design, so we will first draw the model of our design. So focus is on aspect of interest is concurrency. So we are focusing on concurrency, model animation to visualize the behavior, and mechanical verification of properties. So we will see this both safety and progress in LTSA. How we have to achieve the safety and progress. Then models are described using state machines known as label transition systems, LTS. So we are describing our model using the LTS state machines. We have different states and we are then move from one state to another, similar to the FSP and the automata. In automata, we learn that we are in one state, then on some input, we move to the another state like that. So these are described textually as a finite state processes, FSP, and displayed and analyzed by the LTSA analysis tool. So in Arc Studio, what we have seen is we are drawing the connector and component. That is the interface for drawing the architecture. And then in the background, it is converted to XML. So, and similarly here, we are drawing in FSP. So these are described textually as finite state processes and displayed and analyzed by the LTSA analysis tool. So we will write down some textually in FSP and then it will be displayed in LTSA analysis tool. So here are some short form. For LTSA is graphical form and FSP is algebraic form. So we will write in algebraic form and we will get in graphical form. Here is a simple example. So how to model a process? So a process is the execution of a sequential program. It is modeled as a finite state machine which transits from state to state by executing a sequence of atomic action. So suppose we are in this state, first state, and now we are moving from on, when the input is on, we are moving from 0 to 1. So it is modeled as a finite state machine which transits from state to state by executing a sequence of atomic actions. And again from 1, when the input is off, we are going to 0. So it is for a light switch. So it will like on, off, you can see. It will be kept on changing from 0 to 1, 1 to 0. So this is in LTS. We will write in algebraic form and we will get this LTS. So from this slide, I will open the LTSA and you will see alongside this slide, these slides. So I will share the LTSA now. Okay, it has opened. Okay, it is visible. LTSA. LTS analyzer. I will copy this. So here in LTS, I will read the first line. If X is an action and a P is a process. So just remember what I am saying. We will see the example. Then you will get a clear idea. So if X is an action and a P is a process, then X, this arrow, and P describes a process that initially engages in the action X and then behaves exactly as described by P. So we have some action X, and then when the action, so we have this action X and then a P. So after completing this X, it will go to P and will behave exactly as described by P. So this is a simple notation. So we will see example of how it works. And there are some rules, some convention. So actions begin with lowercase letters. So this X before the arrow begins with lowercase letters and processes begins with uppercase letters. So for process, we will use uppercase letters, and for action X, we will use lowercase letter. This is important, X, arrow, and P. So X are actions and P are processes. So after completing the action, then it will move to P and it will behave exactly as described by the P. So P will be further action. So let me cut this. So we have seen the switch example in our PPT. So that same example we will write down in an algebraic form now. So here I am using uppercase letters for a process. So I will first write down the whole code, then I will explain it. So here this on and on, you can see this on action. It's in small letter and then we have in capital letters on. So that was the syntax. And this was action, then followed by a process on. So after completing this on, it will go to this on. It's the process and whatever is defined for this on, it will move on to that. So for this on, we have this last line. So for this process, we have this last line. So after completing this, we will move to this process, and whatever for this on, we will execute that one. So it will start with switch, then it will go to off because we have assigned off to switch. Then whatever is declared for off, so we have for off this action and process. And again for on, we have declared this one. And the syntax, again you have to give a comma at the end, and on the last line you have to give a full stop. Now here you can see three tabs. We have edit, output, and draw. So right now there's nothing because we haven't compiled it. So here you can see You have compile option, you have compose option, then minimize, or in the build menu we can see we have pass, compile, compose and minimize. So you can go to build, compile. So you can see it is showing compiled switch. So this is our main edit option. So after compiling it, so we have this output. It is successfully compiled, and in the draw now you can see we have switch. Now after clicking on this switch, you will get this. Now it is similar to what we have seen in the PPT. It is for a switch. Now to check it, so we have a menu check. So here we have this state 0 and 1. From 0, when the input is on, we are going to 1, and when it is off, we are going to 0. So it is a state machine. Now we can go to check.
Sir.
Yeah.
Sir, but we have written in the code as on and off. So that on it goes to process on, and for action off it goes to process off.
Yeah. Okay.
So
Then
it has taken 0 1 as by default for on and off.
this
0 and 1, yes.
this 0 and 1, yeah, it is by default. You don't have to give the.
So for on it has taken 1, and for off it has taken already 0.
Yeah.
Right, sir.
So this is our initial state. Initial state will be 0. From that, it will go on and off.
What if we have more than 2 states? More than
We will see more than 2 states. It will give 0, 1, 2, 3. It will number like that. It will start from 0 and it will subsequently give the numbers from 0, 1, 2, 3, 4 like that.
Yes, sir.
Ingole will give them the dining philosopher problem, okay?
Yes, sir.
Ingole,
yes, sir.
They will do in the lab or they will do assignment next class? करके लाएंगे.
Sir, assignment that problem.
Okay, that's assignment. So in the book it is given 4 philosophers with 4 forks, and we'll give you with 5 forks the dining philosopher problem. You have read it in operating system how to model that using LTSA with 5 philosopher. Okay, so it is an assignment for next Tuesday रात तक आप करके भेजोगे इंगोले भैया का पास यूजिंग LTSA. Keep that thing in mind. Dining philosopher problem. Okay, this is an assignment for next Tuesday evening by 5 p.m. you will send, and Ingole Bhaiya will check it and tell about your performance on next Wednesday morning. Okay, go ahead.
So here, so after getting this, we go to check. There we have safety, progress, and run. So these 3 commands are important: safety, progress, and run. So first we will go to run. So we have default option, and we have this animator. So what is this animator is? The LTSA animator can be used to produce traces. So this animator is used for trace. So here you can see the click is on. So after clicking on, I have it's showing off. And this is a small example, so you might get confused. So we will see a little complex example. So there you will get a clear idea how it works, this animator. So it is changing state as I click on and off. So here the tick options are eligible for selection. So this on. So if I click on off, nothing is happening. So the tick of actions are eligible for selection. So okay. and in the LTSC, the last action is highlighted in red. So what was the last action? It is highlighted in red. So the last action was on, and now we can the eligible action is off. So we can click on off. So the last action was off, and the next eligible action is on. It's like we have switch on the light. So now we can't again switch on the light. So the next eligible action is only we can switch off the light. So we are off. So the last action was we switch off the light, and the next action we can do is on. So the only eligible action is on. So we can't switch off the light again if it's switched off already. So that's why we only have this on as eligible action. So it will like this. Okay. So this is the animator. I will close it. So now, okay, let me go again. Now in the check we have safety. So safety is to check if there is a deadlock in our system. So in operating system we have seen what is a deadlock. So to check if there is a deadlock in our model, we will go to safety, and here you can see no deadlocks and errors. So we will see an example how a deadlock will occur. So right here there is no deadlock. So you can check in the safety if there is deadlock or not. So here you can see no deadlocks or errors. So this is a simple example for a switch. So let's see an example of a traffic light now. So we can comment this. So now here there were only two states. Now we will see more than two states. Again, capital letters. Traffic light, we have red light. So after red, for orange. So then after orange, we have green. Then after green, again, for slowing down, we have orange. And again, we are coming back to process. So at the end of every statement, we have to end at a process only. Now, so here we start from traffic light. So red, orange, green, orange, and again we are coming back to traffic light. So go to compile. You can directly compile from here. Compiled your traffic light, successfully compiled. So now see, we will see. We can increase the size. So now here you can see the states, how it is number 0, 1, 2, and 3. So from 0 on red, it's going to 1. From 1 on orange, it's going to 2. And from 2 on green, it's going to 3. And again, it's coming back to 0 on orange. It's similar to our code, red, orange, green, again coming back to orange. Then traffic light. So let's check it again. So safety. So okay, no deadlocks and errors are there. So we will run it. So right now the eligible action or eligible selection, we have only red. We can't click on orange or green. But we are starting from red. So after clicking on red, so the last action was red. So the next eligible action is orange. So from red, you can't directly go to green. So the only eligible action is red or clicking on orange. So we are going to green. So here the last action was orange. So again on clicking on green and again red. Here you can see red, orange, green, orange, red. So it will continuously behave like that. You can't directly jump from one state to another state. From red directly you can't go to green. From green you can't directly go to red. So you have to follow these states. So this was for a traffic light. I will close this animator. Let comment this. So let me copy this.
विकास आप पूछते नहीं हो विकास you ask if you have any doubt you ask विकास कुमार
यस सर
आप चुपचाप खराटे मार रहे हो मेरे को सुनाई दे रहा है कि पढ़ने की आदत बना रखे हो ना क्या है why didn't you ask जैसे how states are changing how states are changing ये तो बढ़िया है मेरी स्टेट चार्ट डायग्राम को कंफर्म करने के लिए वैलिडेशन करने के लिए यूएमएल की आप ये बताते हैं ये सेंटेंस क्यों मैं आपके मुंह से नहीं सुना है पढ़ने की थोड़ी सी भी इंटरेस्ट नहीं is a very good model for validating state chart diagram of your UML. How states are changing. आप सही ढंग से state chart diagram बना रहे हो कि नहीं? LTSA model. Ask how it can help.
सर
So here you can see. So if x and y are actions, then we have x arrow p, action and process, and then again we have y and q. Describes the process which initially engages in either of the action x or y. So after the first action has occurred, the subsequent behavior is described by p. If the first action was x and q, if the second action was y. So here we have options. We can either go with x or either go with y. We will see example of this also. So we have here a choice. We can either go with the x or either go with the y. Okay, we will see an example for this choice. So it should be in capital letters. Again, action should be in small letters. So here we starting from drink. So we have red coffee, again drinks, or we have blue tea, or again drinks. So here we can see we have two options. So let's compile it first. So it is compiled successfully. Now let's see the diagram. So here you can see we have two loops. So first one is blue. So the color is just for understanding purpose. It has no meaning. So if you select blue, we will get tea. If you select red, we will get a coffee. So we have actions. We have different choices. So here you can see. So we have tick in red box, red and blue. So these are eligible for selection, red and blue. So we have choices here. You can either go for red, either go for blue. So let's click red first. So the last action highlighted in red. So our last action was red, and the next eligible for selection is coffee. So we don't have any other option. So we have to go with coffee after selecting red. So now select coffee. Now again you can see we have red and blue. This time I will go for blue for tea. So blue, now I have tea. So choices and the let me close this first. So here you can see. So this is the syntax. You have to give up this pipe symbol for choices. So now there was a concept of deterministic and non-deterministic. So Let me give one more example. So now here we have a coin. From coin we have toss. We can go for heads. Or we have toss. We can go for from toss to tails. So the first one, the first example we have seen for drinks, it is a deterministic, and this one is a non-deterministic. So how we can see first? So let me compile this first. It is compiled successfully. So here you can see from the starting state 0, we have start state 0. So on toss, in the previous example, we had two options, tea and coffee, and we are selecting red and blue. So on red, we are selecting coffee, and for blue, we are selecting tea. So here we have toss. So on toss, we are going to tails and heads. So there we have two options, red and blue. So on red, it will selecting one state. On blue, it will selecting another state. But for here on toss, we are going to two different state. So on selecting toss only, we have two states, different states. So it is not deterministic. Because in the previous one, we have different options. We can choose different path based on the input. But here for a same input, the same toss input, we have two different paths. For the same toss, we are going for tails and heads. So it is non-deterministic. So let's check how it behaves in the animator. So I will click on the toss. So that's the only eligible. It's only eligible for selection. So the last action was toss. It selected head. So now it will randomly select. Now there's no algorithm how it will. So it will select tails or heads. It will randomly select head or tail. So now eligible action is head. So again we are going to toss. Now you don't know it will select heads or tails. So it's like a real life toss only. So this time it has selected tails. So the last time it was up to us what we want, coffee or tea. So we are selecting accordingly red or blue. So but here we are selecting toss. So we don't know. So it's going to be a head or tails. Again it has selected heads. It has selected tails now. So again, it has selected tails. Here you can see. So we have toss, then we have heads, then we have tail, heads, then again we have tail, tail. So it will select randomly. It is non-deterministic. So on a single input, we have more than one states. We are reaching to more than one states on a single input. So next we will see guarded action. Let me comment this first. Here you can see the choice when the choice we have when B X arrow P or Y arrow Q means that when the guard B is true, then the action X and Y are both eligible to be chosen. Otherwise, if B is false, then the action X can't be chosen. So it's like our if else statement when we will write some condition. So when B is true, we can proceed, otherwise we can't. So it's the guard condition or guard action. We see an example of this also. So the syntax is when, the keyword uh, when some guard condition, it's represented and regular action and processes.
Sir,
Yeah.
sir, is there any representation for final state or initial state?
So will allow zero as the initial state. There's nothing like, so it will depends how you are writing the algebraic form.
Okay, sir.
So we will see an example of a count. So we will count from like 1 to 3 how a counter will work. So let me write. I will start with count. So here you can see the guard condition when. So I'm writing I is less than and taking action. Count one. We go count. When we have, just wait a second. So we are when I is greater than 0, we have decrease. So we will start with count n is equal to 3. So these are some facilities we can use here in LTSA. So we can start with count. So this n should be capital. Three. Count 0. And again this I. So now this I square bracket count square bracket I. So it signifies that I will start from 0 to n the values. So 0 dot dot n means I will start from 0 to n. I will loop from 0 to n. So when I is less than n, so our action is increment and we are going to count I plus 1. So again this, and when I is greater than 0, we can decrement count I minus 1. So let's check this. If it's compiled successfully. Okay, it has compiled successfully. We can increase the size of this. Okay. So as we have selected n is equal to 3, we can see we can increment it 3 times, increment and third increment. And again we have decrement. This is the model we have get. So let's check it. So this is the animator. Now we can see the only eligible selection. So we have increment. Let's click on increment. So now here you can see both are eligible, increment and decrement both are eligible. So from 0 we have 1. So now again we can increment it or we can decrement it. So again, so you can see both are eligible. So again I'm incrementing. So now here you can see after 3 clicks, because we have taken n is equal to 3, after 3 increments, only decrement is eligible, because we can't go beyond 3. Our counter is up to 3 only. So if I decrement it by 1, then both will be eligible, because it is on 2 now. You can go to increment, or otherwise you can again decrement it. So again it's coming to 1. So from the diagram also you can tell from 1 it can go to 0 or it can go to 2. So that's why we have both the increment and decrement eligible. So let's increment it. It's gone to 3. Again we have 2 choices. Now 0. From 0 we can only go to 1 on increment. So that's why we have only one box selected, increment. So here we are using the guard condition. So this was the example of a guard condition. So let me close this. So you can check this for safety, if is there a deadlock or not. So no deadlocks or errors. There was a one more example for buffers. We will see that. So let me comment this first. The previously we have used it in a count. So count I from 0 to n. This is a example of that only. So in buffer in, so I'm going from I, the values of I from 0 to 3. So we have buffer which has value from 0 to 3, and we are just taking the values out. So from 0, 1, 2, so we are taking each value out of the buffer. We will get a clear idea after I will compile this. You can see it's getting a little bit complicated now. So, okay, now let's run the animator. So here you can see the eligible boxes. So we can in 0, in 1, in 2, or in 3. And from the diagram also you can see from buffer 0. So from 0 either you can go to 1, 2, 3, or 4. So all the 4 options are available. So from 0 either you can go to 1, 2, 3, or 4. So if I select input 2, so it will give last action was input 2. So it is highlighted by red. Only eligible output. So again it has come to 0. You can go to again input 1. So this is just to give an idea of how a buffer, you can use a buffer.
Sir,
Yeah.
sir, for input 1, 3 and 4, the output is different. So how?
Sorry, what?
For
For
just like
input,
for input ones, for input. Okay, okay, sorry.
yeah. For a respect to like if you taking 0, output is 0, 1 for 1, 2, 2, and 3, 3 like this for respect to numbers. So this example for if you want to use this in this buffer. So we have used it in count. So let me comment this. Now we will see
Hello,
an
sir.
example.
Hello.
Yeah.
Sir, in that previous example, that count example, uh, can you please explain the first line? This count n equals to 3 equals to count 0. Like why we are having this count 0 here? Is that the initial
So
step?
we are starting from the 0 state. So we have 3, 0, 1, 2. So
Okay.
to start from the first state to 0 state. So that's why we are taking count is equal to 0.
Okay. Sir.
So we will see some example of constant and range. How to declare constant and range. You just give me a second. So now we will see how we can use constant and range. So all these are different aspects of this LTSA, buffer, count, range. So after writing some models, you will get familiar to it. It's not that difficult. So how to use this constant and range. So let me give an example of this. Constant. Then range. Just remember the text for range, how we are declaring from 0 Here, this example is for adding two numbers. So the range I am taking is for t 0 to n and for r 0 to 2 into n, because if we add two numbers in the range 0 to n, so it can't be greater than 2n. So we have some. The example we have seen before, buffer. So same is here in. There we have chosen, so you can check a simultaneous buffer and this sum I am writing right now. So in there I have written I, here I am using a. So instead of t you can write 0 to n also, one and the same thing, because see for t is 0 to n, the same thing it's there t, and in the buffer also we have written 0 to 3, it's the same thing, range t 0 to n. I am writing, so I am selecting a b. So I am selecting two numbers. So you want to add two numbers now. So I am selecting a in range 0 to n, and I am selecting b in range 0 to n. So t represents range 0 to n. A plus small letters. Again, R, you can see the range for R 0 to 2n, and S is just a variable. So we have declared constant n is equal to 1, range 0 to n for t, and the range for R is 0 to 2n. Then sum. Now we are selecting one number from for A and B. Then we are then we are executing the process total. So we have, wait, so we have A and B. And again, then we have total yes. And again, a range of R is 0 to 2n out. So let me compile this. It is compiled successfully. Okay. So it will take all the instances, all the possible traces. Use the word trace. So the word trace you can remember. So all the possible traces of this model, whatever possible traces are there. So here you can see. So first run it. So first let me. So here you can see our range is n is equal to 1 only. So we can choose only two numbers, 0 and 1, because our range was 1 only. So we can choose only two numbers, 0 and 1. So it's like binary. Because we have chosen n is equal to 1, we have only two numbers, 0 and 1. So what are the all possible traces for 0 and 1? So it can be 0, 0, 0, 1, 1, 0 or 1, 1. So that's why we have got this 1, 1. So it has kept 0, 1 and 1, 0 similar in one stage only. And then we have 0, 0. So all these four are eligible. So if I click on 0, 0, I get 0. So this was the this was the previous input you have selected in 0 0, and the next will be then out 0. So again it has come to initial state. So again we have 4 options, and this time I will select 1 1. So output is 2. So again we have 4 state. So let me change the range. So if I take n is equal to, let me cut, just wait a minute. So if you took n is equal to, now here you can see we have n is equal to 2. So now the possible options we have from 0 to 2. So let's check. Let me first compile it. Okay, you can see the number of states now. You can increase the size. Here you can see all the traces. So we can select 0 0. We can go with 0 1 1 0. Then we can go with 0 2 1 1 and 2 0. Then 1 2 2 1 and 2 2. So all the possible traces we have got here. So let's see the animator for this. Here you can see all the eligible actions. So we have all these 0 0 0 1 0 2 1 0 1 1 1 2. Let's select this 2 0. For 2 0, we have got the output 2. And click this. And again you can see for 0 2 1 1 and 2 0, we have the same input. So we are going to the same state. Because the output is same for 2 plus 0 is 2, 1 plus 1 is 2, and 2 plus 0 is 2. So all the three the same states. So for 1 0 we are getting 1. So similarly,
Sir,
yeah,
can you please show the code for a minute?
yeah, wait. Let me close this. So here we have constant n is equal to 2. Then we have taken two range 0 to n and 0 to 2 into n. Then we have sum in, we are selecting two numbers, a in the range 0 to n, b in the range 0 to n. And then total we have a plus b. Let's try to make some changes. If we take the range 0 to n, let's see if we get some error. So here you can see total 3 defined to be error because we have changed the range 0 to n. So you will get such kind of errors, warnings if you have any error in your code. it should be 2n. We will see example of a timer now, how a timer will, so how the code for timer will be. So in timer we will start from 0. And after 1, we can stop after 1 minute. We can stop after 1. We can stop after 2, 3, 4 like this. So it will count till whatever value we have specified. So we have n is equal to 4, 5. So it will count till 0, 1, 2, 3, 4, 5. Or we can stop before the till it reach the n value. We can stop before that also. So I will comment this. So let's see our timer. Should be in capital. This is the range 0 to n. Use the guard condition here. When I is greater than 0, Again, I am giving another guard condition. 0. So let's check it. How our LTSA will look. It is compiled successfully. So here you can see we are starting from 0, 0th state. Then we have start. So again, first check the code first. Just remember the code for. Again, I am this. So you can see countdown n is equal to 3. We are starting. So again, we have countdown n. So from the second line, we have countdown I 0 to n. So whenever I is greater than 0, so we have tick, and again we are reducing the count 1. Or if when I is equal to 0, we are going from beep to stop, and at any time we can stop. Similarly, we are starting from 0 to start. So first tick, second, third, and then when I is equal to 0, we have beep. And similarly, so in the last condition, the last was stop. So from every state you can see we can go to last state. So from 1 you can stop, you can go to last state. From second also you can see the stop. From third also you can see, and from fourth also you can see. So why we can go from every state? Because of this last. Again, I will go to our code. So you can see the last one, stop. It will be applicable to every state. It has no guard condition written for that. For tick, we have guard condition whenever I is greater than 0. So whenever I is greater than 0, we have tick. And for beep, whenever I is equal to 0, so we have beep for that. So that's why we have tick. So that's why you can see we have tick for every state. So we have n is equal to 3. So we have n is equal to 3. So when from 1 tick, so n is equal to 2. So again n is equal to 1. And the third tick, we have n is equal to 0 now. So whenever I is equal to 0, we are getting beep. So now let's check the animator. So in the from 0, so you can check the diagram. So from 0 we have only start. We don't have anything else. We don't have any other option from 0. We can only go for start. So let's click on start. So here you can see from 1, we have 2 possible states. You can either go to last state stop. I just want to stop from here, or you can increment the timer tick. So let's increment it first, tick. Now it has gone to second state 2. Again, we can see here 2 options, stop and tick. Again, you have 2 options, stop and tick. And now it's the last one. So I is equal to 0 now, and stop. So we have come to the last state. So now from here we can't go back to the first state. So now we don't have any eligible boxes. So let me check the progress of safety of this. So now here you can see it's saying trace to deadlock. Start and stop. You can see in analyzing, you can see depth is equal to 3 and it's saying trace to deadlock. So you can check in safety. So why it is a deadlock? So here you can see after reaching the 5th state, you can't go anywhere. It is just a deadlock. Because this is example of our countdown. So you can check the in safety that if whether the model is in deadlock or not. So this is in deadlock because after reaching the 5th state, we can't go back to the first state.
Sir,
Yeah.
sir, show the code.
Okay. Okay, yes. You see the code countdown. So you can see the beep for only when I is equal to 0. Stop is eligible for every state, and the tick is eligible only when I is greater than 0.
Sir,
Yeah.
sir, here in this first line, the countdown n is equals to 3. We from start we go to countdown, and in bracket we have n.
Yeah.
Why did why didn't it get the countdown as 3? Countdown bracket 3 from start.
Yeah, we can write countdown in bracket 3 also. No problem. It's same thing, and we have declared n is equal to 3. So instead of n, you can write down 3 directly.
So,
Countdown 3.
so the very first line is a declaration.
Yeah, it's a declaration. You can say it's kind of declaration. N is equal to 3.
And our program starts from the second line.
Yeah.
Yes, sir.
We have seen similarly in the count. We have count n is equal to 3. We have count 0. It's similar to that. So this one is for a counter. Now we will see something about concurrency and parallelism. So when we say something is concurrent or something is parallel, so in concurrency we say it's logically simultaneous processing. So I will give you one example. So we have two processes A and B. So what happened is the first process A, will run for 1 millisecond and it will stop. Then it will go to our processor will give time to process B. It will again run for 1 millisecond. So this will happen continuously. It will give 1 millisecond for this process A. It will give 1 millisecond for process B. So, but as a user, what we will find that so it will look like they are running in parallel. So we can't find out the difference that okay, this process A is stopping, B is running, again B is stopping, and A is running. So it will be so fast that it seems like they are in parallel. They are running parallelly, but actually they are not running parallelly. Process A is stopping, process B is running, again process B is stopping, process A is running. So this is concurrency, like logically simultaneous processing. It's we are calling it logical. So it's not actually happening, but logically it seems that they are running parallelly, but actually both the processes are stopping and running. They are giving chance to each other. So that is in the parallelism. What we have is physically simultaneous processing. So here we have process A and process B, and both are running simultaneously. So both have their own CPU. So both are parallel, both are running at the same time. They are not sharing the CPU. As in concurrency. In concurrency, we are sharing the CPU. First process is sharing, and the second process first, second. But it's happening so fast. It seems that they are running parallelly. That's why we are saying it logically simultaneous processing for concurrency. Here I will write. Here concurrency is logically simultaneous and parallelism is physical simultaneous. Actually, the both process A and process B are running simultaneously. So you can note this down: concurrency and parallelism. We will see an example of this parallelism. So we will see example of parallelism. So here we have, so a person is in conversation with someone. So he is doing a conversation. So actions are, he will first think, then he will talk, and then he will stop. These are some of the basic actions. So a person is first thinking, then he is talking, and then stop. And the second action I am taking is itch. So he feels the urge to itch, so he will scratch. So these are the two processes. The person is someone and he feels the urge to scratch. He feels urge, so he will scratch. So these are two actions. So we will see how these two actions will be done. So how parallelism will be used here. So this is the symbol we use for whenever you want to use parallel. So these two pipe symbols. We'll give one name. And again. Let me check the syntax. So we have conversation, think, talk, and stop. And whenever he feels urge to scratch, so he will scratch and stop. So we have these two actions. Then so we have used converse and parallel each. So we have used these two actions in parallel. So again, you can read the code. Then we will move on to compile it and we will see the LTS. Okay, we have some error. You can see process identifier expected. We have converse, think, we have talk, we have stop, then we have each. Should be it should be a full stop at the end of this first two lines. So again, let me compile this. The converse is compiled, not found for each. Error is if we have written okay, so
Sir, after converse, we would have full stop, right? Rather than semicolon or rather than comma.
yeah, that's what Okay, it has compiled successfully. So we need a full stop at the end. So both has compiled successfully. Now let's go to draw. Now here you can see as we are using parallelism, so we have two different LTS. We have for one converse and one for each. This is the first one, converse. We have the person is thinking, think and talk. And the second one is each. So he will scratch and each. So okay, so we have these two. We have converse. So think, talk, and we have each. Okay, so we have these two in parallel. So let's take it, run, default. So here you can see the eligible boxes. We have think, we have scratch. So we have think, and for each we have scratch. So I will click on think. Going to talk, scratch, and again talk. So it's ending in a deadlock. Let me again run. So if we'll check in the safety, it will show trace to deadlock, think, talk, and scratch. And the possible traces here, as we have two different. So we have think and talk, and we have each. So what are the possible traces here as they are running in parallel? So I'll just write down. We have think, and talk. So these are the three possible traces. So they are, because they are running in parallel, so we can select first think, then scratch, and again talk. Or we have think, talk, and then scratch, or we have first scratch, then think and talk. So these are the three possible traces because they are running in parallel. That's why we have these three possible traces. Here, and it is in deadlock because we are not moving from this last state. So this is about the parallelism. Now we'll see an example of a shared action. I will write down if to say so you can read if a process in a composition have actions in common, these actions are said to be shared actions. So we say example of this, what these common actions are. If the compositions have actions, common actions. So So yes, one more line I will write. Here you can see while unshared actions may be arbitrarily interleaved, a shared action must be executed at the same time by all processes that participate in the shared actions. So you can again read both these two lines. So you will get an idea. And then we will see example of this. So what is shared action? So process in a composition have actions in common. In the above example, we have conversation and we have each. So there are no common actions in them. We have think, talk, stop, different, and we have scratch, stop, different. Actions I am talking about, think and talk and scratch. So suppose we had think, talk, and scratch, and again scratch means there is a common action in them. So that will be shared actions. So we'll see example of that. And while unshared actions may be arbitrarily interleaved, a shared action must be executed at the same time by all processes. If there is a shared action, that has to be executed at the same time. We have seen the similar kind of syntax before. So the syntax is just the question we have seen for that think and scratch, this conversation and scratch. The only difference you can see here is so here in maker you can see we have make ready, again maker, and we have ready. So this ready is a shared action between these two. So ready is a shared action between maker and user. You can see the difference between the first and the second. In the previous one, we had totally different actions for a maker and user, for think and conversation and each. We have totally different actions, but here we have one common action ready. So it is called as shared action. So we will now check it in the animator. Now remember the second point. A shared action must be executed at the same time by all processes that participate in the shared action. Now let's compile it. Successfully compile. First, I will show you separately. So we have maker, make, and ready. So we will consider he will make a cake, and then it will be ready. And the user, whenever it is ready, the user will eat it. So he will use. So make ready, and use. So ready is a share action in maker and user. Now let's check. Now here it is interesting. So we will start with make. So the only eligible state in the start is make. So let's see what happened if we click on make. So it has gone to ready, first state. In user, there is nothing right now. So it is simple till now. We have clicked on the last state highlighted in red. Now it has come to ready, one. So now here you can see after clicking the ready, we have two states, make and use. This is the user. For user, the last state was ready. And the maker, the last state was ready. Let me go to again the previous. Okay, so from here we have started before. So now we have make. I am clicking on make. Now here you can see for maker, the next action is ready, and for user, the first action is ready. Both are happening simultaneously. A shared action must be executed at the same time by all processes that participate in the shared actions. Must be executed at the same time. You can see now. Now this ready is shared action. So for maker, it's the next action, and for user is this first one. So now when I click ready, you can see both are red now. And you can see for maker, the last action was ready, and for user also. Both has happened simultaneously. And now for user, we have use next one use. So that's why we use is eligible. And for maker, so we have make, the next one is eligible. That's why make is ready. So if I click now on use, so use, now second one is ready, but it's not till eligible because there's nothing the user can take. So I will click on make. Again, it's ready. I can make and use. So here ready is the shared action. You can check it here again. We can repeat this animator. You will get an idea how it's working, how the shared action is working. So any doubt in this one, the shared action? Should I explain it again?
Anybody has doubt?
No, sir, not in this, sir, but
राकेश राकेश कुमार तुम्हारी डाउट है? रणवीर?
नो सर।
रणवीर सिंह, कोई डाउट है पूछो, चुपचाप बैठ रहे हो क्यों?
Shubham, sir.
Yeah.
हाँ,
Sir, my code is not working, means compilation error is coming. Can I share?
You can share the screen.
hello, yeah, good morning, good Preetham, after a long time. yeah, yeah. Yeah. So very long gap. After a very long gap, we are talking, and particularly due to this COVID problem, again the gap has increased further.
Yeah, Pratik, open the editor.
Yeah. Okay, doing fine. I have one.
So you have countdown n is equal to 3 from start. You have counted down n. See I is equal I from 0 to, okay, so we have written it's 0 or O, that inside the countdown I colon uh, it's O or 0. Yeah, okay. N again, check it, compile it. Okay, still error. Okay, come back to edit. So when I is greater than 0, using tick count down I minus 1 when I is so I is equal to 0. Beep stop and then okay, check it again. Okay, they compiled successfully. Open the diagram, draw LTS. Click on LT countdown. Okay, you can expand it. Okay, so you have start. Okay, yeah, you have got it. Where is the animator? You open the animator. Okay, run. Check animator. Run and default. Okay, so it is running. The animator is not visible to us.
Hello, sir.
Yeah.
Now is it visible?
No, the animator is not visible.
Sir.
So it is visible to you.
Yes, sir.
Actually, it's because of the screen. I think it's only sharing the LTS analyzer. It's not sharing the animator. Okay, anyway, it's working properly. So you
Sir
can stop.
means only stop is coming on animator.
The stop is coming
Yes, sir.
because I can't see the animator. That's so. Let me check. So we have start. Tick tick tick. So we have stop. Wait a second. Again, open the editor code.
Visible, sir.
Yeah, it's visible. So let me check it first. 0 and I get
Sir, it
0.
is working fine. He is in dead state.
Okay, that's why. We have to again run it.
Yes,
We
sir.
have reached the dead state. That's why it's not running again. So again, compile it. Okay, come to countdown. Okay, yeah, it will run. So once it reach the dead state, we have to compile it again. So it's working properly now.
Yes, sir. Means after start, it's coming to that state.
Yeah, it will work like that only. Just click the tick now. If after start, click the tick.
Yes, sir. Yes.
Yeah.
Okay, sir.
Once it goes to last state, it will be in a dead state, so you can't move on from there. This one is for our concurrency and parallelism. So there was one more for deadlock, how a deadlock will happen. I will comment. So what is the deadlock state is transition. This is the definition here. So deadlock state is one with no outgoing transition. So in the previous counter we have seen from the last fifth state we have no outgoing transition. That's why in the safety, if you check it, it will show deadlock, trace to deadlock. Let's write down a simple example for a deadlock. Coming to this deadlock, north, south, north, south. Take the diagram, you get idea what this code does. The code, so we are north, south move, and then we have options north to stop and south. Here you can see from zero first, zero start state. On north, we are going to first. From north, we are going to this two. We have two options from there. We can either go again north and again we can go to south. So this second state, no outgoing transition. So if we will check it, so we'll run it. It won't show it here. So from north, after clicking north, again we are north or south. I click south, it will work properly. Again, it will coming to this zero. So we have north, south. We can do like this north, south. But again, I click on north from 1, it will go to 2, and now we are in a dead state. So we don't have any outgoing transition from this one. You can check the deadlock for safety here. So you can see trace to deadlock, north and north. So it will give a trace from which state to where we are going to deadlock. So here from north and north, if you are giving these two inputs, north and north, we are reaching to a dead state. So it's a trace to deadlock. You can see we are north, north. So this trace will lead to a deadlock. So you can check in safety. So let's move to our editor. So again, I am giving a quick overview of from where we started. From the simple one, we have started from the switch. So first, let me comment. So again, I'm giving a quick overview. Everyone can pay attention. The first one we have seen is switch. One we have off. From off, we are going to on. Again, we are going to. It's like a cycle. You can see from on, we are going to this one. Again, from this one, we are going to this one. On and off. Compile it. You can check. On, off. It will go on. So it's a simple one, a switch. I'll test for switch. So what if we here you can see it, you can do it like this also. So I have removed this switch is equal to off. Directly from off on, it will be in cycle. But you can start it like this also. So you can check both the differences. I can write like this also. Off state, I have input on, and then I am going to the on process, capital one, capitals. On, I have the input off, and I am going to the off process. So both are valid from on and off. The next one we have seen is for the drinks. If you have choices, two or more choices, let's see that one. Let me comment. This is the second. So again we have drinks. So from red we have coffee, we have tea, simple one. So there will be, you can see two circles, one for each one. The first one, if you choose blue, you have tea. If you choose red, you have coffee. This is deterministic one. Because on different input, we have different outputs. Very simple. For red, you have coffee. Again, you have drinks. For red, you have coffee. And the next one we have seen is it's non-deterministic. So we have coin, toss. So again, on the same input, we have two outputs. For toss, we have heads and tails. And from heads, we have heads, so coin. And for a similar input, we have two different outputs, so it is non-deterministic. So you can see for toss, same input, you have two outputs, tail and heads. Let's check it. So toss, it will give us a random output. So this time heads, tails, heads, it will give us different random outputs. It's like tossing a coin. Here you can see first we have tails, heads, heads, heads again. You have tails. So randomly it will choose anything. This is for non. In the next one, we have taken count and starting. So we are choosing n from. So it's like a loop. We have a guard condition when I is less than n. We have moved to increment in process count I plus 1. We are increasing the value of I plus 1. I is greater than 0. So we have two choices. We either go for increment or increment, decrement. Here you can see whenever when I goes greater than 0, then both this condition we can apply. Either we can increment or we can decrement, because I is greater than 0. So this is also valid. Increment. So now I is 1. So we have two options, decrement or increment. I will decrement it. Again, we have one option, increment. We have two options again, decrement or increment. I will increase it. So again, we have now one option only because we have one outgoing state only. You can check decrement, decrement, increment. So like this, you can check it's working properly. And no deadlocks because every state has some outgoing transition.
Sir,
Yeah.
sir, if we want to show only increments, sir, then what change we should make?
You can remove this. Will end up in that state. Now I have, wait a minute. Now I have removed the decrement. Now let's check, now check the code first. So when I get less than n, increment count I plus 1, that's it, end. So I have removed the decrement one, decrement guard condition. Let's compile it, check it. Now here you can see just increment. There's no transitions for decrement. So it will. So we have a state which has no outgoing transition. So it will let in deadlock. Use animator. Here you can see we have only increment, 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 and just stop last one. So it's not dead state here. We check it in the safety and give us when it will lead to deadlock. Trace to deadlock when we have three increments, 1, 2, and 3 deadlock. You can change the value of n is equal to suppose 10. I will take. Here we have got 10 increments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We change this count 0 to 4. We have changed this count to 4. It's starting from the fourth one. So we will have only 6 states. Just play with it how it changes the output. 10 count. We are starting from 0. Slide is that. When I is greater than n, increment. So whatever you write in this section, small letters, it will be on the transition line, on the arc. So I minus 1. If working, so yes. Oh no, wait. We have decrement, so we have count. It is showing something else. It should be I should be greater than 0. That is wrong. So compile it again. Now you can see it is for 10. It's a counter for n is equal to 10. What if I write down I minus 2 here? Just checking what happens if I am decrementing it by 2, I minus 2. So I also don't know what will happen. So it's one count minus 1 defined to be error. So we can't go minus 2. So the next one we have This example is for how to use this loop. I from 0. We are taking one 3 in, 3 out, 0, 1, 2, 3, in and out, everything. For addition of two numbers, we are taking constant and 0 to n. Then we have r from 0 to 2n. A is from first. We are going to total a plus, and then we have received a plus b is a total. So here the next line total is yes, and it should be in the range out here. So, okay, there's some syntax error. Twenty. Check the error. What is the error we are facing?
Sir, it should be 2 multiplied by n.
Okay,
It-
here. Yeah, it's compiled now. This one we have got for this. For the countdown, this one is a good example. So n is equal to 3. From start we are going to count down n. And for countdown I 0 to n. When your I is greater than 0, t, we are going to the next state. When I is equal to 0 and last stop, then is for everyone. Here you can check the guard condition. Stop, it will be present for every state. There is no guard condition for stop, it will be present for every state. There is guard condition for tick and beep. So it will be there only when this condition is valid. So stop condition is for every state. No, we are on, and again for this countdown we have all the further states. So from start we are going to count down. So from start we are going to this one. Now from 1 we have stopped for every state. Whenever I is less than n, we have tick. Now I is equal to 0. We have beep and stop. The previous one was start. From here you have stop. We have tick. I can click tick. From here it's going to here. Tick again tick. Now beep I is equal to 0. Dead. Last step. It's a deadlock. Let me add one step. See if it will want to go from this last fifth step to again start this first one or this countdown I want to go. when so we have I is equal to 0 beep. Or let's so let's see what happens. I have made some modification. But here it is going from 4. So start, tick, 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 and then it's going to be. Here you can see how I made some modification. The code changes. We can change this stop also. Start. So I will go for peak, peak, peak. Again coming to the first state, you can see tick, 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 tick. Here what changes I have made is after the fourth tick, instead of going to the last state, it's again coming to the first one. You can, so the simple modification I have made, you can see there is no deadlock now for this one. Still there is a deadlock for this last state, but for this one there is no deadlock. So beep, tick, 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 beep. The previous timer was there, you can count down to 5, 4, 3, whatever the number is, and it will stop. But here I made some modification, and after this countdown, we can again start the countdown. After the n is equal to 3, again you can start the countdown. So 1, 2, 3, again beep 1, 2, 3. But I would stop. It's built state. Let's check what happens. I have made some modification again here. Countdown instead of stop, I have written countdown n. Let's see what happens. This is perfect. Run default. So start on start. I'm coming here. 1, 2, 3. Again beep. Again I'm coming to first. Again beep, and it's working properly. Stop. Let's see the modifications are made here. So previously, what was happening? We are countdown was till 3, and after that we will reaching the dead state. It was the last state. So I made some modification in the code. So if you have the previous code, so I made a count. So I have changed this countdown, I think, and I have changed this stop. So whenever I is equal to 0 means we have reached the end of the countdown. We are again starting the countdown from n. Countdown and n, we can see here. And whenever we click stop, again we are starting from the countdown n. I start. So we are here 1, 1, 2. Okay, wait. 2. Okay, 1, 2, 3. And again, it is coming to the first one. You can see first 1, 2, 3. Again, first. You can check. And after, suppose I want to stop, I can again come to the first state. If I can come to the first state, you can see, and no deadlocks. So the previous one we had deadlocks. So here we don't have any deadlocks. No deadlocks or errors. Just a simple modifications I made, and you can see there are no deadlocks. We have changed the count to countdown. You can note this down. So the next one we have seen is for parallel. So we have parallel activity. File. So these two we have. When run it as it's a deadlock from top you are going. Okay, so because for parallel, if you want to two activities in parallel, you can number of traces here will be 3. So these are the 3 possible traces for these two parallelly running activities. The sequence of think and talk will always be before talk. This. Then you have seen for shared action. This one we don't have any shared action now. So we have ready as a. So it will simultaneously happen in both maker and user. We have maker user. Try this also at home. Might not get it in the first try. So make, so it will go for the first one. Now after clicking ready, both maker and user. So there is ready in user also and ready in maker also. So you can see in user also we have a ready, in maker also we have a ready, and both are red. Both are red means the previous actions in both red and maker and user was ready. Both has happened simultaneously. Now again I can choose anyone. I can choose use, make. So again ready. So both has happened simultaneously, maker and user. This one was the this one was for the deadlock. We don't have any, how do we try? So okay, that's it for the LTSA. So if anyone has any difficulty, they can ask.
Kulkarni, Shubham Kulkarni. Any difficulty? Shubham.
I'm doing.
अरे तुम्हारी बड़ा भाई है, तुम्हारी गांव का बाजू वाला. You ask उसमें why do you feel shy? कोई भी डाउट है पूछो.
Yes.
You are so lucky to get such a brilliant elder brother. You are so lucky. For 2.5 hours he went on telling. You boys are so lucky to get such a brilliant boy, such a brilliant elder brother. So take the advantage of his brilliance. Ask him whatever, any guard condition applied, Shubham Kulkarni. How does it help, the guard conditions?
So to
Shubham
avoid,
Kulkarni.
so to avoid the conditions which we don't want to happen.
Okay. You will be using this guard condition in Petrinet. Okay?
Yes, sir. Okay.
after 1 or 2 classes. So there you will compare how the guard condition of LTSA works, how the guard condition of Petrinet works. What is the difference? How does it help? How does it create problem? You make a comparison after 1 day. After one Wednesday, we will have that Petrinet class. There also it is being used, guard condition. So there you will have a comparative analysis between LTSA and Petrinet analysis. Anyway, anybody? प्रतीक जायसवाल, तुम्हारी और कुछ डाउट नहीं? प्रतीक,
No, sir. No, sir.
पूरा बढ़िया से you have understood?
Yes, sir.
5 लड़के जो आज नहीं आए हैं, अंद्रीला, महेंद्र, सिद्धार्थ, बानोत और कौन है? आशुतोष, उन लोग को तुम समझा सकोगे पूरा बढ़िया से? ना इससे बेहतर? सर शुभम भैया कुछ नहीं समझाए, मैं उससे ज्यादा ही बढ़िया समझा दूंगा, ऐसा बात है प्रतीक जायसवाल?
No, sir. Shubham sir is like very good student.
No, he's a good boy. He's a good boy. You have to salute him. You have to salute him. You are lucky enough to get such a good elder brother. You are lucky
Yes,
enough.
sir.
You are
Yes.
lucky enough. Oh, her line, her comma, her full stop, he is explaining so in detail. I am very fortunate enough to get him as my student. I am very fortunate. So you should take advantage of him. So today's class, half hour, you see, 2.5 hours, he went on telling. Any doubt, you just ask him Rahul Sahu. Rahul Sahu, तुम राहुल गांधी मत बनो, पूछो राहुल साहू।
Sir, yes.
मैं तुम्हारी ज्यादा क्वेश्चन नहीं दिख रहा हूँ। I want to see more question from your mouth. तुम चुपचाप
2-3 question I have asked.
2-3 नहीं, 20-30 पूछोगे तो मेरे को खुश लगेगा, नहीं तो मेरी इंप्रेशन ये राहुल गांधी बन गया। अच्छा, ओके। निर्मल, you don't have any doubt? Nirmal Panda?
No, sir.
You have to explain to Siddharth. You see, Siddharth remained absent.
Yes, sir.
That's not attitude problem. It is such a nice class, 2.5 hours class. Can anybody afford to remain absent? Mahendra Sharma, though, he has some virus in his brain. He's constantly remaining absent. Anyway, choice is yours, जिसकी जो दिखाई देगा। अगर कोई जानबूझ के अंधा रहेगा तो how far I can help? I cannot help a blind boy. I cannot help those who want to intentionally remain blind. Anyway, और कुछ नहीं। Next class क्या करवाओगे? इंगोले, शुभम इंगोले?
So we can start a Petrinet or a Z specification, anyone.
Okay, Petrinet कर लो, क्योंकि ना ये गार्ड कंडीशन उधर भी जरूरत पड़ेगी, ठीक है ना?
Yes.
तो ये Petrinet कर ही लो नेक्स्ट क्लास में, ठीक है?
Yes.
Okay.
Shubham sir,
Yeah.
please scroll down the LTS analyzer. Okay, sir. From shared action. Yes, sir. Okay, sir. From shared action. Yes, sir. Okay.
क्या डाउट है तुम्हारी प्रतीक?
No, sir. Actually, sir, in starting of the class, my LTA tool is not working. Then I install JDK. Then I started. That's why little bit late. That's why I'm taking a screenshot of the last thing.
अच्छा. So all the students have got the LTSA tool in your system. Everybody has got Jitendra Gora. आपकी सिस्टम में आप डाउनलोड किए हो? जितेंद्र गोरा?
Yes, sir. It's working in my system. Yeah.
It's working in my system. Good. आप ट्राई करो, कैसे इम्प्रूव करोगे, ये तो बेसिक चीज इन्होंने बताया. What are the other things I can add to it? I can improve upon it. That is your interest. उसमें आपको दिखाई देगा कि सर ये नहीं बताए, ये हम कर सकते हैं. अच्छा. Anyway, So assignment for everybody. Coming Tuesday, dining philosopher problem with 5 philosopher and 5 forks and 5 spoons. 5 forks, 5 spoons. Dining philosopher problem. 5 forks, 5 spoons. You have to send the answer using LTSA on Tuesday by 5 p.m. and on next class, he will explain you and he will tell you how you will do it using Petrinet. Okay? So my request to you, don't kill time on Saturday, Sunday. I am not taking class on Saturday, Sunday. I am allowing you to study this, do this dining philosopher problem on Saturday. Friday, Saturday, Sunday, 3 days you are having holidays. So don't kill time, apply your own brain. Friday, do you have class? Do you have class Friday? My class, you do. Other classes you are having, na?
Yes,
Rishabh?
sir.
Okay,
Yes, sir.
okay. Other
Yes.
classes you are. Yeah. Okay. You don't have my class. I'm not taking class on Saturday. I'm giving you time for doing this job. Dining philosopher problem with 5 philosophers, 5 spoons, 5 forks. Okay? How you can avoid deadlock. As you did using guard condition here, think of how you can do it there. How the different guard conditions will help you. And one of you will explain, I'll call in the next Wednesday to explain how you have done. So come everyone with your PPT to explain to any layman ढंग से आप जैसे बता सकोगे. राइट हैंड साइड इमेज, लेफ्ट हैंड साइड टेक्स्ट. टेक्स्ट एकदम बढ़िया क्लास 1 के लड़का जैसे समझ पाएगा. How a class 1 boy can understand. So you write the text in that fashion. So PPT, I will call Somu or anyone randomly, Jitendra or anybody I will call randomly, Nirmal or anybody I will call randomly. You have to explain on the next Wednesday. But before that, complete your assignment, send it to Ingole Bhaiya. Don't copy paste. Do your own intelligence with your own intelligence. आप ही सीखोगे. इंगोले भैया को तो सब पता है. उनको सीखना नहीं है, आपको सीखना है. Your intelligence, you have to improve. So do it by yourself. Okay? Okay, this is now 11:40. Now, till today, the basic architecture, description, languages, ADL. LTSA is again one ADL. LTSA, Arc Studio, Acme. We covered 3. We could डार्विन आपने किया? डार्विन किया था ना नहीं इंगोले? डार्विन हम लोग का था ना, तुम लोग का बैच में नहीं हुआ था डार्विन?
नहीं हुआ था. आर स्टूडियो, एक्मे एंड एलटीएसए.
देखो जरा तो कोशिश करो. डार्विन पहले लड़के करते थे, मेरी जो इंप्रेशन है. जरा ढूंढो तो, ठीक है?
यस सर, देखूंगा.
जरा ढूंढो. Also लड़को, boys, you also try. If at all you can get Darwin, call Ingole Bhaiya, send him Darwin. Earlier some boys used to do Darwin. I remember that. जरा देखो तो, ठीक है? लेकिन हाथ में टाइम नहीं है, और क्योंकि ये कोरोना के टाइम में सब लेट क्लास शुरू हुआ तो टाइम हाथ में नहीं है. यू डोंट हैव मच टाइम इन हैंड. फिर भी अगर हो पाएगा तो एक डिफरेंट, लिटिल बिट डिफरेंट आप अगर कर ही पाओगे तो बढ़िया बात है. वो बात गया. अच्छा, मैंने भेजा हूं 2 लड़कों का पास भेजा हूं. बाकी लोग सब 2 लड़के आप लोग का पास भेज देंगे. कुछ असाइनमेंट जो कि लैब असाइनमेंट के लिए चाहिए, आप एक्मे यूज कर सकते हो, ये आर्ट स्टूडियो यूज कर सकते हो, एलटीएसए यूज कर सकते हो, और तीनों कर सकते हो. एंड बढ़िया से करना है. क्या करना है? मैंने दिया हूं रैंडमली इस तरह का एक एप्लीकेशन सॉफ्टवेयर. आई हैव सेंट टू बॉयज, वन टू ऋषभ एंड वन टू राहुल, टू सेंड द मेल टू एवरीबॉडी. ओके, Rishabh and Rahul, you have got a mail in your mail inbox. You forward it to your friends.
Yes, sir.
Yes,
या
sir.
हाँ, आप देख लो, आप खरीदोगे प्लीज, ठीक है। विकास कुमार, आपको आज देखना है एक फेसबुक या इंस्टाग्राम या कुछ भी एक सोशल नेटवर्क कैसे पोर्टल बनाओगे, ठीक है। विकास कुमार,
ओके सर, ओके सर।
आप पढ़ो फेसबुक की, इंस्टाग्राम की या कुछ भी एक सॉफ्टवेयर की पोर्टल कैसे बनाते हैं। आप अलग से विकास उसको फेसबुक नाम नहीं देकर मैं अगर रखूंगा विकास, तो विकास की सॉफ्टवेयर कैसे लोग पसंद करेंगे सोशल नेटवर्क के लिए। ओके, फर्स्ट राइट डाउन द SRS, सेंड द SRS टू इंगोले भैया बाय कमिंग ट्यूसडे। ओके, आप
ओके
दो तीन पढ़ने का बाद आपको आइडिया बन जाएगी कि ऐसे ये सॉफ्टवेयर बनाते हैं, and I will develop a separate software better than Facebook, better than Instagram, better than others. इसमें या खूबी है, ये प्रॉब्लम है, ये प्रॉब्लम है, I can do in a better way by following the proper architectural analysis using UML, using Arc Studio, using कुछ जो मेरे को बेस्ट लगेगा, I will use it and I will do a better software than that. आप लिख लो, ठीक है। सोशल नेटवर्क पोर्टल, ठीक है। आप नेक्स्ट ट्यूसडे को आप भेजोगे 5 बजे तक उसका SRS, सॉफ्टवेयर रिक्वायरमेंट स्पेसिफिकेशन। ओके, आप पढ़ो, पढ़ने के बाद मेरे से अगर कुछ भी डाउट है तो मेरे को अगर आप मेरे से डिस्कस करना चाहोगे, ऑलवेज फ्री। सैटरडे मॉर्निंग इस समय हम लोग आ सकते हैं, सैटरडे आफ्टरनून आ सकते हैं। आई एम फ्री ऑन सैटरडे। एनीबॉडी वांट्स टू मेक डिस्कशन, you just tell me 4-15 times Saturday. If at all you want, I can give you more detail regarding the software specification. ठीक है, आप सैटरडे को अगर चाहोगे, if you want, I am there. So if you want, you give mail that on Saturday, sir, I want to show my SRS to you. तो उसके बाद हम लोग थोड़ा सा इम्प्रूव करके तुम ट्यूसडे को भेज सकते हो। यू कैन सेंड टू इंगोले भैया, ठीक है। ओके। जितेंद्र गोरा, मैं सोचा हूँ जॉब पोर्टल इंडिया में क्या क्या सब है, naukri.com ये सब है ना इंडिया में, उससे बेहतर जो हर वर्ल्ड का एवरी एरिया में फॉलो करते हैं, मैं शुरू क्लास में बताया शुरू से, एक indeed.com, ठीक है। आप उससे बेहतर कैसे बना पाओगे, उसमें क्या प्रॉब्लम है, आप उससे बेहतर कैसे बना पाओगे। आप सोचो, एनी टाइप ऑफ जॉब के लिए आप हाउ द इंफॉर्मेशन यू कैन गिव टू एन एप्लीकेंट एंड how you can collect the CV from the applicant to the provide it to the job provider. Then their next phases of recruitment, job portal. Okay, Indeed. Okay, आप पढ़ो थोड़ा, मैं किसी को गोदी में नहीं बैठाना चाहता हूँ, आप खुद कोशिश करो चलने की, खुद पढ़ो। अगर आपकी डाउट है, आई एम ऑलवेज देयर। ओके 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 ओके। आशुतोष गुप्ता, क्या प्रतीक जायसवाल, आशुतोष गुप्ता की आज तबीयत खराब है? प्रतीक
यस सर।
आशुतोष की क्या हालत, क्या आज एब्सेंट क्यों रहा? Why remained absent?
Sir, don't know about why he remain absent, but he is means discharged from hospital before.
Can anybody afford ये 2.5 घंटे की इंगोले भैया की इतना मेहनत, कोई उसको ठुकरा सकता है? Can anybody afford to miss such a nice explanation on LTSA? Can anybody, इतना अंधा कोई बन सकता है? घर में हो, घर में you can, if you have interest, you are having avenues, everything. Anyway, मैं और बोलना नहीं चाहता हूँ। Anyway, आशुतोष का जायसवाल, प्रतीक जायसवाल, मैं आपके लिए बहुत बड़ा सॉफ्टवेयर की सपना देखे हूँ, ठीक है? आप
Yes,
बिजनेस की फैमिली के हो, किराने दुकान मान लो, एक बड़का सा किराना दुकान,
yes, sir.
वॉलमार्ट हैज गॉट, कितना चेन है देख लो. It
Yes.
sells from needle to car. Okay,
Yes, sir.
so you are going to set up a Pratik Mart in Newark. Okay,
Yes, sir.
प्रतीक मार्ट आपकी कैसे रिटेल स्टोर फॉलोइंग द कंसेप्ट ऑफ सप्लाई चेन आप टक्कर दे सकोगे, ठीक है? सोचो व्हाट आर द हाउ यू कैन मैनेज. उसमें क्या प्रॉब्लम रहता है? इन्वेंट्री क्या है? स्टॉक.
Yes, sir.
स्टॉक कितना रखोगे, मीट कर पाओगे, कोई कस्टमर वापस ना चले जाए. कोई नीडल लेने के लिए आए या तो बुक लेने के लिए आए या कुछ भी लेने के लिए आए, यू मेंटेन द गुडविल ऑफ द कस्टमर, ठीक है?
Yes, sir.
तो आपकी प्रतीक मार्ट ये कैसे बेहतर होगा वॉलमार्ट से? वॉलमार्ट के कितना है ब्रांचेस? मे बी मोर देन 5000. आप देख लो, ठीक है?
Yes.
यू चेक इट एंड थिंक ऑफ SRS लिखो. अगर आपको कोई डाउट है, मैं जो बोला इन्वेंट्री मैनेजमेंट सबसे बड़ा इसमें प्रॉब्लम है, वो क्या है इन्वेंट्री मैनेजमेंट, थोड़ा आज पढ़ लो. अगर आपकी कोई हेल्प चाहिए, यू कैन टेल मी, आई कैन ओपन माय सिस्टम ऑन सैटरडे एट 4:15. ओके,
Okay, sir.
आप थोड़ा पढ़ लो, पहले पढ़ो, पहले यू इम्प्रूव योर नॉलेज, देन यू टॉक विथ मी. ओके ओके
Yes.
प्रतीक, ओके बाय बाय. देन प्रतीक का बाद शुभम कुलकर्णी.
Yes, sir.
कहाँ आप रहते हो शुभम कुलकर्णी? वेयर डू यू स्टे?
Aurangabad, sir. Aurangabad, Maharashtra.
औरंगाबाद में एक छोटी सी एयरपोर्ट है, ठीक है?
Yes, sir.
तो मैं औरंगाबाद की एयरपोर्ट देखे हो और एक बड़ी एयरपोर्ट बॉम्बे की देखे हो?
Yes, sir.
देखे हो कि नहीं? ना नहीं देखे?
देखा सर, देखा है.
देखा हो, ओके. तो तुमको औरंगाबाद को एयरपोर्ट को बॉम्बे एयरपोर्ट से बड़ा बनाना है. मैं तुमको उसकी मैनेजर बनवा दिया, ठीक है?
Okay,
क्या
sir.
क्या उसमें फैसिलिटी रहना चाहिए, किस तरह का उसको बेहतर बना पाओगे? एयरपोर्ट मैनेजमेंट, एक एयरपोर्ट अथॉरिटी ऑफ इंडिया एक है ना,
Yes, sir.
एयरपोर्ट अथॉरिटी AAI. I am making you the chief of airport authority of India and you want to make the airport of Aurangabad bigger than that of Mumbai, ठीक है?
Okay, sir.
So what are the features, how you will do it, how you will plan it, उसके लिए सोचो. SRS धीरे धीरे लिखने के लिए प्रयास करो. And if at all you have anything in mind, you can call me. Okay?
Okay, sir.
Okay, fine. I want you should learn by yourself. Okay.
Yes.
Rikaj.
Yes, sir.
Okay. Rikaj, I am thinking about giving you vehicle management in a city. Vehicle. आप दिल्ली में हो. दिल्ली में कितना सारा, how many vehicles are there starting from Luna to उसका बाद मोपेड से motorcycle, scooter, different varieties, then cars, then jeeps, then trucks, then buses. So all these things, one office manages it. That is the RTO office of Delhi, Regional Transport Officer. मैं आपको आज बना दिया RTO of Delhi. So what are the things he does? What are these activities he does? रिकाज ने एक मोटर बाइक खरीदा from this shop and goes with a vouch, that invoice that he has paid 75,000 for a motorbike, for example. Then he reaches the RTO office. Okay. So he paid some tax for his motorcycle. For example, ये कुछ बजाज पल्सर है, मान लो कि 150 सीसी का, उसके लिए कुछ टैक्स है. अगर उसका पास ज्यादा पैसा है, क्या आजकल सब यूज करते हैं ना, बहुत फॉरेन में, क्या प्रतीक बताओ, क्या डेविड हल्लेसन ना क्या है जो हाईफाई है,
डॉल्बी सर,
डॉल्बी, और एक
हार्ली डेविडसन,
हाँ हार्ले डेविड,
हार्ली डेविडसन,
हार्ले डेविडसन. वो कितना सीसी की है? हाउ मच सीसी? एनीवे दैट आई डोंट नो. ये तो जनरल जीके क्वेश्चन. आप करोड़पति कैसे बनोगे अमिताभ बच्चन की? एनीवे, so what I mean to say is Bajaj Pulsar registration fee and Harley Davidson something, that registration fee is 1200 cc. Bajaj Pulsar 150.
Yes sir, 220.
220 वो है 1200, वो है 1200. So the registration fee is different. What I mean to say is, रेखा चेक करो, ये वो 220 cc 1200, इसके लिए what are the registration charges? How does it depends on your cc capacity? cc capacity. मैं एक मारुति 800 खरीद करूंगा और ये एक प्रतीक एक खरीद करेगा एक हाईफाई गाड़ी, क्या टेस्ला ना क्या एक है हाईफाई कार, टेस्ला.
यस सर, टेस्ला.
हाँ, समथिंग मोस्ट एक्सपेंसिव कार प्रतीक का है. मेरे लिए रजिस्ट्रेशन फी मान लो कि 5000, प्रतीक के लिए हाउ डिपेंड्स ऑन द सीसी, टेस्ला के लिए. ऑल दिस थिंग, एक बस के लिए कुछ, एक ट्रक के लिए, ट्रक रेगुलर चक्का कितना, रेगुलर 6 चक्का ना कितना, रेगुलर ट्रक 6 चक्का के लिए आजकल 16 चक्का वाला भी आती है, उसके लिए कितना. सो इट ऑल डिपेंड्स ऑन द कैपेसिटी ऑफ द व्हीकल. सब तो मैं रेकाज एक खरीद करेगा तो एक एक्टिवा, होंडा एक्टिवा, उसके लिए कुछ, स्कूटर के लिए कार एक लेगा मारुति 800, तो मारुति आल्टो, उसके लिए कुछ. प्रतीक उसका साथ जाएगा टेस्ला लेके, उसके लिए कुछ. हाउ? सो दे मेक सम कैलकुलेशन बेस्ड ऑन द सीसी. एक बस, एक कार, एक जीप, सब अलग अलग रजिस्ट्रेशन फी. देन रजिस्ट्रेशन वो लोग नहीं करेंगे जब तक सम कंडीशंस आर फुलफिल्ड. क्या कंडीशन है? उसके लिए इंश्योरेंस आप दिए हो कि नहीं, उसके लिए आप क्या पोल्यूशन चेक किए हो कि नहीं. दीज आर द कंडीशंस. देन ओनली दे डू द, देन ओनली LTSA की. So you have to do all these things. You have to do all these things. Think of how you can develop an application software helpful for the RTO of Delhi. आप खुद RTO हो, आप कैसे एक बना पाओगे आपके लिए? How you can do a good software? This will give you very practical exposure. एंड आप सोचोगे क्यों मैं हमेशा क्लास डे 1 से बोल रहा हूँ, 68% इन द ऑफ द सॉफ्टवेयर इन द होल वर्ल्ड गो टू द ड्रेन, गो टू द डस्टबिन, बिकॉज दे डोंट प्लान इट प्रॉपरली ऑन द बेसिस ऑफ इट्स आर्किटेक्चर. वर्ल्ड भर की 68, कितना बड़ी नंबर है, दे आर थ्रोन टू द डस्टबिन बिकॉज लैक ऑफ प्लानिंग. एनीवे, आप देखो, अगर आपकी कोई हेल्प चाहिए, आई एम देयर. रेखा जी, ओके. आप थोड़ा पढ़ो, आप उसके धीरे धीरे SRS लिखने के लिए प्रयास करो, ठीक है?
Yes.
ओके, ओके, फाइन. निर्मल पंडा.
Yes, sir.
Nirmal Panda, I am thinking to give you an assignment on port management. Port. There are a lot of ports in our country. Calcutta Port, Port, Vizag Port, Madras Port, then Cochin Port, then Bombay Port. So all these are, then I think some ports are there in Gujarat also. Anyway, so big ports are Bombay, Calcutta, Madras and Cochin. Okay. These are the 4 big ports. So for example, Calcutta Port. The Calcutta Port manages different types of ships. Some ships go from Calcutta to Andaman taking passengers. Some ships send cargo. Cargo are of different types. Some ships, the cargo are either from Paradip, the iron ores are being sent. So for that, different type of ships. From Bombay High, ONGC oil is being extracted. So oil tankers are there in Bombay port. How they are berthed, berthed, berth. In the train you have seen berth. So likewise, in the port there are berths where the ships come and take the particular position in the bank of a sea for loading and unloading. So that is called berth, berth. So you go through that. Okay. You are the chief manager of Calcutta Port or a Cochin Port or a Bombay Port or a Paradip Port or a Vizag Port. How you can manage in Calcutta Port both the passengers as well as the cargo. Just you see, these are the different application softwares. If you develop something, then only in your job you have the idea how to develop similar type of job, similar type of assignments. Okay.
Yes.
Now you are doing a very regular software. Next class, how it will be web-based. You will put it in the web so that everybody can access it. Yeah. Next semester, we will make it web-based. You will learn slowly how you can make it Google Web or Amazon Web. You will slowly learn based on our study on SOA. So if you do something now, you will learn something more in the next class because your society is moving towards web-based development. Anyway, Nirmal is port. Then Siddharth is absent. Andrila is absent. Ranveer.
Yes, sir.
Ranveer, बोलो तुम बोलो कुछ. These are the different assignments I have thought of. मेरे को कुछ सोचने के लिए help करो.
Sir, I wrote a Olympic.
Olympic, you have already got it. Okay. Now और कुछ तुम अच्छा सोचे हो? Have you ever thought something better? कुछ अपने लिए? Okay. ओलंपिक मैंने सोचा हूं. अगर आप कोई चेंज करना चाहते हो तो यू आर ऑलवेज वेलकम. मैं हमेशा देता हूं बहुत बड़ा सॉफ्टवेयर. आप सोचो, मैं प्रतीक को टक्कर देना चाहता हूं वॉलमार्ट दैट लाइन, बिकॉज द प्रॉब्लम बिकम्स मोर डिफिकल्ट व्हेन द साइज बिकम्स लार्जर. सो ओलंपिक में कितना गेम रहता है? 4 साल का बाद होता है. How you plan for that? कैसे नॉकआउट गेम्स ऑफ फुटबॉल, कैसे तुम्हारा नॉकआउट से होते होते इंडिया हट जाती है इंडिया, कैसे कितना कंट्री को लेके नॉकआउट मैचेस होता है. तो कब से प्लान शुरू करना पड़ता है, कहां कैसे. आई थिंक सम ओलंपिक इज गोइंग टू टेक प्लेस इन टोक्यो, आई थिंक, राइट? 22 or something like that.
Yes, sir. 2020 it was going to be held, but it postponed to the next year because of Corona.
Sir, summer 2021.
Summer 2021. अच्छा.
Yes, sir.
Something like that. Okay, okay. What I mean, देखो, एक ओलंपिक के लिए 4 साल पहले उसके लिए बिडिंग होती है. कौन ढंग से संभाल पाएगा? इंडिया को मिलता नहीं है, फुल ओलंपिक मिलता नहीं है, क्योंकि इंडिया बिड नहीं कर पा रहा है इतना फैसिलिटी अरेंज करवाने के लिए. 4 साल पहले उसका नॉकआउट कितना गेम रहता है? मे बी अराउंड 30-40 different type of varieties of sports, swimming, cycling, racing का slow, fast, kitna marathon, both varieties. So you check how many types of games are there, how you plan for it, कितना country को लेके knockout करते जाओगे आप, ताकि लास्ट में आपको वही इवेंट का टाइम 7 कितना कंट्री पार्टिसिपेट करते हैं मेरे को पता नहीं, 7 या 9 कंट्री आप लेके जाओगे फाइनल इवेंट के लिए. 9 कंट्री से आप 1, 2, 3 चुनोगे. तो हाउ यू प्लान दैट? बड़ी चीज है प्लानिंग. 4 साल पहले कहां कैसे आप प्लान करोगे, एंड अकॉर्डिंगली योर सॉफ्टवेयर विल कीप ट्रैक ऑफ इट. एवरीथिंग इज सॉफ्टवेयर बेस्ड. ओके, आप पढ़ो थोड़ा, उसका बाद अगर आपकी मदद चाहिए, आई एम ऑलवेज देयर, यू कैन ऑलवेज डिस्कस. If you tell me, I will open my system at 4:15 on Saturday. Okay.
Okay, sir.
Somo.
Yes, sir. Yes, sir.
Yeah. So you have seen what is the assignment to you?
Yes, sir. Hotel chain.
Hotel chain. What is the biggest chain? Hotel chain. Which hotel is the biggest chain in the world? Did you check?
Yes, sir.
Which chain? Which hotel has got the biggest chain?
I think Radical something like that.
Something. Check properly. Which chain, Prateek? Which chain? In India, I think
Marriott.
Tata, Marriott. Okay, Marriott मैंने मान लिया. How many hotels are there Marriott के?
Sir, 427,000.
427,000.
No, sir, 427, I think.
2 थप्पड़ खाएगा.
So that are rooms, sir. 427,000 rooms.
अरे बाबू, कितना होटल कितना जगह में है?
Yes, sir. Location, sir.
How many places it has got? Anyway, you check it. I think Tata must be having more than 100. जो टाटा में जहां पर कैसाब वगैरह फायरिंग किए थे ना बॉम्बे में, उस तरह का इंडिया में 100 होगा. मैं टाटा होटल के चीफ बना दिया. आई मेड सोमू एज द चीफ ऑफ टाटा चेन. आप देख लो सोमू. ओके.
Okay, sir. Okay.
So Tata must be having more than 100 in different places all through the country. So likewise, Marriott must be having more than, my guesswork goes 5,000.
Sir, they are means they are showing depending on guest room, means which is having more guest room.
हाँ, कितना एवरेज जो स्टैंडर्ड होटल है कितना? एक तो फिगर बोलो. एक जैसे मैंने बोला कि टाटा का 100 होगा कंट्री में, तो इस तरह का, जस्ट फॉर योर इंफॉर्मेशन आई एम टेलिंग यू, चेक इट लेटर ऑन. आई एम नॉट गोइंग टू डिबेट ऑन इट. एनीवे, तो मैं रतन टाटा नंबर 2 बना दिया सोमू को. ही इज द चीफ ऑफ ऑल द 100 होटल्स. He is the chief of all the. How he can efficiently manage all the hotels in equal footing. एक छोटी सी होटल है उड़ीसा में, एक जगह है, पहले पोर्ट था गोपालपुर पोर्ट करके, वहां पर एक छोटी सी टाटा की एक होटल है, आप देख लो. So what I mean to say is they give equal importance to a small Tata hotel at Gopalpur and a big Tata hotel at Bombay. You are the chief of the Tata company. For you, all the hotels are of equal importance. So how you can manage 100 hotels in India? You are Ratan Tata number 2. show how your software will keep track of, उसमें भी वही प्रतीक का जो है इन्वेंट्री आइटम, इन्वेंट्री मतलब स्टॉक, क्या क्या स्टॉक है तुम्हारी, बेडशीट पिलो से शुरू करके द डिफरेंट फूड आइटम्स of the hotels, different facilities, everything are being managed in the stock. How you keep the stock ready for your customer.
Sir,
It's
I
a very
got
small.
it, sir. 7,000.
बोलो
Sir,
बोलो.
7,484 number of location Marriott is means placed.
And Tata का देखो तो Tata. So Pratik got, Marriott has got 7,484. At these places, Marriott has got a big hotel in Delhi, in Calcutta. I have stayed there. It's very big, very well organized. I have stayed. Okay. So,
The
okay.
Tata is only 160.
160. Okay, only 160. 160 भी मैनेज करना इतना आसान नहीं है. ठीक है, मैं थोड़ा सा, I'm coming, somebody is calling me. Just give me 5 minutes break. I am coming. Just excuse me. I'm just coming. Somebody is calling me.
Yes, I will take the attendance. विकास कुमार. विकास.
Sir, he is having some battery problem, but
Jitendra?
he said.
Jitendra.
Yes, sir.
Asim. Asim is up. Asim, then Ashutosh. Ashutosh. Pratik.
Yes, sir. Yes, sir.
Shubham.
Yes, sir.
Rikaz.
Yes, sir. Present, sir.
Rikaz.
Hello, present, sir.
Nirmal Chandra Panda.
Present, sir.
Siddharth. Andrila. Ranveer.
Yes, sir, present.
Somshekar.
Present, sir.
Rishabh.
Present, sir.
Rishabh.
Present, sir.
Akshay Kumar. Akshay Kumar absent. Rahul Sahu.
Present, sir.
Present, sir. Shivam.
Rakesh.
Yes, sir. Rakesh present.
Yeah, and Mahendra Kumar Sharma.
Hello, sir.
Yeah. Oh, Mahendra.
Sir, Akshay is present, sir. He is saying mic is not working from his end.
And Mahendra Kumar. Mahendra absent. Absent. Ashutosh absent. Mohammad Rikaz absent. Siddharth absent. Andrila absent.
Sir, आया हूँ मैं. Hello, sir. Shubham, sir. Shubham, sir. Mohammed Vikas present, sir.
Okay, Mohammed is present. Okay, wait a minute.
Sir, Vikas Kumar, sir.
Sorry, who?
Vikas Kumar, sir.
Vikas Kumar.
Yes, sir. Present, sir.
Yeah, I am marked present.
Chandrakant, sir. Sir, Chandrakant.
Sorry,
Chandrakant, sir.
Chandrakant. Okay, Chandrakant is absent. Mahendra Kumar. Mahendra Kumar is absent. And
Sir, Chandrakant is present, sir.
Chandrakant is present. Mahendra Kumar.
Yes.
Sir will join.
Sir, my LTC is not working, sir. I've tried
LTC is not working.
everything, sir. And no, sir, I have tried everything, sir. You can check, sir. Hello.
Yeah, you have to check. I think JDK. There has to be some problem with JDK.
So JDK 11 is installed, sir. I've checked the version and everything, sir. It's properly installed.
Yeah, other has downloaded it. What is the error?
Sir,
Opening
sir, when I try to open, actually, sir, my file is not showing the executable file. It's only showing the file. There is no file like executable file.
You can share your screen. You can share your screen. You can check.
I'm doing from beginning, sir. Can you see, sir?
It's not visible.
So, see, when I open, sir, it blinks and just goes.
Yes,
Just
please.
download.
This happens. Yes, sir.
Yes, I can. Sorry, I got disturbed. Sorry. Yes, all are here? Allah? Yeah. Hello? Hello?
Yes, sir.
Yeah. So, Somo, you check it. And as,
Okay.
Pratik told that you are the chief of Marriott, which has got 7484 hotels. So likewise, what is the inventory? How do you manage it? How your software checks from a small place to starting from small place to beginning from Bombay, Delhi, Calcutta? How you are the chief of Tata Hotels? How many hotels Tata has, Pratik?
162.
162. Just you see, 162 hotels Tata is managing. And they give equal importance. For you, all are same.
Sir, that's two in 80 location and 17 countries.
Oh, 80. नहीं, इंडिया में कितना है? इंडिया में भी देख लो, लिखा होगा.
Okay, sir. Okay.
Anyway, just an example. I give some example. It's your interest how you search, how you find out. Okay. This is interesting. Starting from bedsheet to soup to any food item, anything. And all the hotels are equally important. Okay, Somu. It's a very good assignment. So think of how efficiently you can do. Rishabh.
Yes, sir.
तुमको एक
Yes, sir.
मिला है? तुमको जो मिला तुम तो देख लिया?
Yes, sir.
कोई
Sir,
हॉस्पिटल चेंज करोगे ना और कुछ बेहतर बनाओगे और कुछ बेहतर कुछ सोचे हो क्या? Anything
Sir,
better have you thought of? Or
Sorry,
that
sir,
one?
अभी तो नहीं सोचा था.
Anyway, तो मैं सोचा हूँ हॉस्पिटल चेन. ये जैसे अभी बताया प्रतीक की इंडिया में टाटा का मान लो कि 100 है. इस तरह का इंडिया में शायद अपोलो का ही सबसे बड़ा चेन है, राइट?
Yes, sir, Apollo.
Apollo ka how many? Maybe 35, 40 hotel, yeah, hospitals are there. Maybe that's my guess. I don't know. Maybe.
Yes, sir.
Yes,
Yes, sir.
yes. एक छोटी सी अपोलो की एक हॉस्पिटल है यहाँ पर मध्य प्रदेश, छत्तीसगढ़ में, बिलासपुर में, समझा? तो मान लो कि एक बिलासपुर में कोई एक पेशेंट आ रहा है, कोई एक पेशेंट, सीरियस पेशेंट है, they start treating at Bilaspur, they fail to treat him at Bilaspur, then they advise him to go to either Chennai or Hyderabad. मान लो, just, they are the big hospitals, okay?
Yes,
so,
sir.
you as the manager of the particular Apollo Bilaspur and Apollo Hyderabad, how you can coordinate the treatment of a patient? How you can transfer the patient from Bilaspur to Hyderabad? All these things. Why Bilaspur doesn't have that type of facility? How you can improve the facility at Bilaspur? ठीक है?
Yes, sir.
What are the facility? Why you want to transfer? ये transfer में बहुत कुछ भी पंगा हो सकता है. माने critical case में life becomes difficult to give the support. Okay? So how you can improve the facilities in Bilaspur, or if not possible, how you can transfer the case from Bilaspur to Hyderabad, Apollo Hospital. Okay, just think of.
Yes,
And
sir.
it is the same. A lot of things are based on this supply chain. This is called supply chain. The same supply chain of Pratik, the same supply chain of Somu and yours. Managing the chains.
Yes, sir.
Okay. Think of, go through it. If you have any doubt, have a talk with me.
Yes, sir.
Okay, first you improve your knowledge base. Akshay Kumar.
Sir.
अक्षय कुमार,
Sir. Yes.
तुमने देख लिया क्या?
Yes,
तुमको
sir.
मैंने, हाँ ना, उससे और कुछ बेहतर तुम करना चाहोगे? कुछ बोलो, आइडिया दो. जो मेरा मन में जो आया मैं भेज दिया.
Sir, I was thinking of clean city.
और ये सेफ होम है, ये कुछ पता है तुमको सेफ होम का बारे?
No, sir.
पता नहीं तो, और क्लीन सिटी क्या? ये मैं दिया हूँ, एक सुन लो.
Yes, sir.
कल शादी करोगे, मान लो कि आप यूके में हो.
Yes, sir.
2 जन, यू एंड योर वाइफ गो फॉर सर्विस.
Yes,
2
sir.
जन जॉब करने जाते हो. घर भगवान की भरोसे में ताला देके जाते हो.
Yes, sir.
कभी कभी भगवान बात नहीं सुनते हैं.
Yes, sir.
कोई बर्गलर अंदर घुस सकता है. आजकल जमाना है खाली शीशा की घर है, जहां देखो खाली शीशा.
Yes, sir.
तो शीशा तो कोई हैमर में टूट सकती है, कोई बंदा घुस सकता है.
Yes, sir.
या दरवाजा का नीचे थोड़ी सी स्पेस है तो आप स्नेक भी घुस सकता है.
Yes, sir.
या आप आए हो फ्रिज में, कहीं पर शॉर्ट सर्किट हुआ तो शॉर्ट सर्किट से आग लग के पूरा घर जल सकता है.
Yes, sir.
तो आप जिस लोकेलिटी में यूके में रह रहे हो, 2 जन हस्बैंड वाइफ, उसी तरह का मान लो कि एक छोटा सा एरिया है जिसमें कि hundreds of people are staying and all are doing job. So how the house can be safe from morning 8 to evening 6?
Yes, sir.
तो उसके लिए क्या आपकी सॉफ्टवेयर हेल्प करेगी? क्या घर में एक सेंसर हर जगह लगाओगे? कोई
Yes, sir.
बंदा, कचड़ा बंदा अगर शीशा तोड़ेगा तो उसका पिक्चर सेंस करके पुलिस को खबर देगा, तुमको खबर देगा कि घर में कोई घुसा.
Yes, sir.
एक स्नेक दरवाजा के नीचे कैसे छोटी सी स्नेक घुस रहा है, तो पिक्चर उठा के तुमको कैसे खबर देगा, पुलिस को कैसे खबर देगा?
Yes.
या तो घर में कहीं फायर हो गया तो कैसे एक लोकेलिटी के लिए एक बड़ा सा बेल कहीं तुम लोग रखोगे, एक बड़ा सा बेल, फायर बेल बजेगी और पुलिस कैसे आएगी, फायर ब्रिगेड वालों कैसे आएंगे, ताकि तुम्हारा घर मॉर्निंग 8 से इवनिंग 6 बजे तक सेफ रहेगा? व्हाट टाइप ऑफ प्रिकॉशन यू विल टेक? ये सारे सॉफ्टवेयर तुमको मैनेज करेगी, तुमको खबर देगी, तुमको मैसेज देगी, तुम्हारा मोबाइल में रिंगटोन आएगा, क्रिंग क्रिंग क्रिंग, घर में आफत, पुलिस को खबर जाएगी, फायर होगी तो फायर ब्रिगेड वालों को खबर जाएगी। तो ऑल दिस हाउ योर सॉफ्टवेयर कैन मैनेज। ठीक है, एक सेफ होम सॉफ्टवेयर एक है, किसमें शायद थोड़ा देख लो, नेट में है एक किताब, शायद इसमें है, शायद प्रेसमैन में है, प्रेसमैन किताब में सेफ होम सॉफ्टवेयर है, देख लो कैसे बनती है, व्हाट आर दी स्पेसिफिकेशन, और तुम कैसे 100 आदमी के लिए एक सॉफ्टवेयर बनाओगे और कैसे होगे ताकि तुमको सपोर्ट मिलेगा। ठीक है,
ओके सर।
करो, पढ़ो थोड़ा, अगर कोई भी डाउट है आई एम देयर। ओके ओके, राहुल, राहुल साहू,
यस सर।
तुमने देखा तुमको जो मिला?
यस सर, स्टॉक मैनेजमेंट इज देयर।
स्टॉक के बारे कुछ पता है?
अभी तो नहीं पता सर, पढ़ूंगा लेकिन।
अच्छा, ये है सोच, बहुत बढ़िया बहुत बढ़िया, मैं पढ़ूंगा, मैं उसके लिए आई विल बिल्ड अप माय एक्सपर्टाइज। हमेशा बी पॉजिटिव, हमेशा। आई एम हैप्पी। चाइना में इवन क्लास 12 के बाद जो कॉलेज में ज्वाइन करते हैं, पापा जहां पैसा देते हैं, कुछ पैसा बचा कर स्टॉक में लोग इन्वेस्ट करवाते हैं, स्टूडेंट लोग भी स्टॉक में इन्वेस्ट करते हैं। क्यों? बैंक में 4% 5% इंटरेस्ट मिलती है, ज्यादा नहीं।
यस सर।
स्टॉक में अगर आप सोच करके ढंग से स्टॉक में इन्वेस्ट कर पाओगे, तो आप अगर 100 रुपीज इन्वेस्ट किया तो 6 महीना में 120 हो जाएगा। वेराज बैंक में रखोगे तो 6 महीना में 102 होगा। ओके, तो 102 किधर, 120 किधर? तो कौन सी स्टॉक
भी है? रिस्क भी तो होता है सर स्टॉक मार्केट में।
वही ना मैं सोचा, मेरा फर्स्ट सेंटेंस क्या बोला? अगर आप ढंग से सोच करके प्लान करके लगाओगे।
यस सर, यस।
आपकी का प्लानिंग कैसे करोगे? हमेशा हम लोग पास्ट रिकॉर्ड देख के प्लान करते हैं, ये बढ़िया काल बढ़ा था, लेकिन स्टॉक में कुछ पास्ट रिकॉर्ड काम नहीं करता है। तो क्या काम करता है? किस बेसिस पर आप प्रेडिक्ट करोगे कि इस आधार पर मैं प्रेडिक्ट करूंगा ताकि मैं जहां पर आज स्टॉक में लगाऊंगा वो फॉल नहीं करेगी, मेरे को रिटर्न अच्छी देगी। ऑन व्हाट बेसिस यू विल डू द प्रेडिक्शन। ठीक है,
यस सर।
मान लो कि 6 महीना में ये बढ़िया सा बढ़ रहा है, ये कोरोना आ गया कब? फरवरी मार्च में सारे स्टॉक का वैल्यू फॉल कर गया है। किसको पता था कि चाइना वाला इस तरह का पंगा करेंगे? किसी को पता नहीं था। तो यू हैव टू फोरसी किस तरह का पंगा आ सकता है, उससे पहले मैं ये कंपनी से पैसा उठा लूं और दूसरा जगह पैसा कैसे लगाऊं। सारे स्टॉक अभी मार्च से फॉल करके रहा है, लेकिन एक दो स्टॉक भी बढ़ रही है, कुछ कुछ बढ़ रही है। तो वही जो कुछ कुछ बढ़ रही है, कौन सा बढ़ रहा है, कैसे मैं वहां पर लगाऊं, कैसे मैं उसको आइडेंटिफाई कर पाऊं। तो हाँ, पास्ट रिकॉर्ड में मान लो कि एक्सिस बैंक, स्टेट बैंक बढ़िया बढ़ रहा था फरवरी मार्च तक, सडनली चाइना वायरस आया तो पंगा आ गया, हर स्टॉक अभी एकदम नीचे जा रहा है, लेकिन हार्डली 4-5 अच्छा चल रहा है। मैं कैसे वही 4-5 को आइडेंटिफाई करूं और वहां पर इन्वेस्ट करूं, देखो। ठीक है, ठीक है। तो कैसे मैं प्रेडिक्शन, मेरी प्रेडिक्शन एल्गोरिथम कैसे बढ़िया से मैं प्रेडिक्ट कर पाऊंगा, ये देखो। ठीक है,
यस सर, यस सर।
थोड़ा पढ़ो, अगर तुमको कोई भी डाउट है आई एम ऑलवेज देयर। ठीक है,
ओके सर, थैंक यू।
ओके बेटा, ओके ओके। एनीथिंग, एनी डाउट, आई एम देयर। मैं चाहता हूं कि तुम थोड़ा कोशिश करो। चंद्रकांत, चंद्रकांत,
यस सर।
अच्छा तुम हो, ठीक है। आज पूजा करने के लिए नहीं जाओगे? आज खत्म हो गया
नो
पूजा?
सर। यस सर।
अरे छठ तो है संडे को, आज नहीं जाओगे?
नहीं।
आज से पूजा करोगे तो सूर्य भगवान ढंग से तुमको आशीर्वाद करेंगे ना। आज गया क्यों नहीं? बाबू ये विद्या सबसे बड़ा पूजा है। विद्या का मीनिंग क्या है? सा विद्या या विमुक्त है, जो अंधकार से तुमको मुक्ति देता है वही विद्या है। और सूर्य भगवान को क्या तुम मांगोगे? मेरे को अंधकार से मुक्ति दो, और ये तो पहला मुक्ति यहीं पर है।
यस।
और वहां मुक्ति देने के लिए तुम गया था सूर्य भगवान को प्रेयर करने के लिए, गधा। जो तुमको देखना चाहिए तुम देख नहीं पा रहे हो। विद्या सा विद्या या विमुक्त है, जो तुमको मुक्ति देता है, यही विद्या। अंधकार से ये मुक्ति देता है। एनीवे सुनो, और चंद्रकांत में तुमको दिया कुछ एक लाइब्रेरी मैनेजमेंट।
मैनेजमेंट सर।
हाँ लाइब्रेरी मैनेजमेंट ना। तुमको और कुछ चाहिए? बोलो, तुम बोलो, ये मेरी मन से आया, तुम बोलो। और कुछ
आई
है?
थिंक इट्स गुड सर। आई विल डू इट सर।
ओके। लाइब्रेरी, हमेशा मैं चाहता हूं कि तुम बड़ी लाइब्रेरी की सोच रखो। ब्रिटिश लाइब्रेरी, यूके
Yes,
की
sir.
ब्रिटिश लाइब्रेरी सबसे बड़ा है, सबसे बड़ा है। हाउ मेनी बुक्स आर देयर, हाउ मेनी मेंबर्स आर देयर, हाउ दे आर मैनेजिंग। कोई एक ऑर्डर दिया किताब के लिए, ये जो क्या एक ओबामा का लिखा है, कौन सी एक किताब? ओबामा हैज रिटन ए बुक ना yesterday?
Yes, sir. Yes, sir.
क्या बुक है? हाँ
Sir, I just read. I forgot,
I
sir.
just
He wrote
मुंडी में
about
डाल।
Promised
Manmohan
land.
Singh.
है
Promised
Promised
land.
Land। हाँ,
Yes,
मान
sir.
लो कि किताब नहीं है उन लोग का रैक में, प्रतीक ने ऑर्डर दिया, प्रतीक ने ऑर्डर दिया, आज नहीं है किताब, मेरे को परसों तक ला के दो। कितना जल्दी वो लोग ला देंगे? वो किताब न्यूयॉर्क में अवेलेबल है, लंदन परसों तक कैसे मिलेगा? हाउ अर्ली दे कैन गेट। तो
Yes, sir.
लाइब्रेरी में क्या रहता है? किताब रहता है, जर्नल रहता है। जर्नल दो टाइप का होता है, जर्नल रहता है और एक मैगजीन रहता है। मैगजीन
Yes.
और जर्नल में क्या अंतर है? मैगजीन थोड़ा जनरल टाइप की रहता है। मैगजीन, इंडिया टुडे मैगजीन, टाइम्स मैगजीन, जनरल टॉपिक उसमें रहता है। इंडोनेशिया में क्या हिंदू टेम्पल्स आर देयर इन इंडोनेशिया, सो ये आएगा मैगजीन में, जनरल टाइप का टॉपिक। whereas जर्नल में आएगा रिसर्च टॉपिक। रिसर्च, कोई अंदर जाके डीप जाके स्टडी करके जो लिखता है वो जर्नल में छपती है। तो जर्नल, मैगजीन, तुम अभी राउरकेला आओगे, यहाँ पर सारे हम लोग जर्नल मोस्टली फॉलो करते हैं। जर्नल जो कि एक एरिया में सॉफ्टवेयर आर्किटेक्चर का जो LTS है, ये LTS का डिटेल छपेगा जर्नल में, LTS नहीं छपेगी मैगजीन में। अच्छा, तो कितना डिमांड है किताब के लिए? कितना मैं रखूं? तुम हो लाइब्रेरी की चीफ, कितना मैं किताब रखूं, कितना जर्नल रखूं, कैसे डिमांड है, कैसे मैं सब्सक्रिप्शन फीस कितना मैं फिक्स करूं? तुम तो फिलांथ्रोपिक ऑर्गेनाइजेशन नहीं ना, तुम तो कॉस्ट इज इन्वॉल्व ना। तो हाउ यू विल मैनेज योर लाइब्रेरी, हाउ मच कॉस्ट यू विल। कोई अगर किताब राहुल ने नहीं वापस किया, तुम 7 दिन के लिए राहुल को किताब दिया, राहुल नहीं किया, तो पेनाल्टी कैसे तुम इम्पोज करोगे? उसको कैसे खबर दोगे? नहीं दोगे तो ये कैसे तुम उससे रखोगे, राहुल से फिक्स डिपॉजिट, ताकि किताब की कॉस्ट कुछ 25% तुम कवर कर सकोगे। सारे माने कोई बंदा का साथ किसी तरह का प्रॉब्लम हो सकता है, he may not be able to return the book, कई किताब खो जाती है एक्सीडेंटली, तो किताब की दाम ज्यादा है, तुम कितना ही कॉस्ट रखोगे उससे वापस लाने के लिए पैसा, तो ये कुछ डिसीजन तुम कैसे ले पाओगे? बड़ी एक लाइब्रेरी को रेफरेंस लो, ठीक है? ठीक है, ओके, पढ़ो, थोड़ा देखो। ओके बेटे, ठीक है।
Okay,
और
sir.
नेक्स्ट शिवम डालमिया। शिवम, शिवम डालमिया अभी था नहीं? शिवम, am I not audible?
Audible, sir. He was there at the time of attendance.
उफ, ये सब एटीट्यूड, सोच की बीमारी, मेरे को गुस्सा लगता है। मैं सोच करके रखा हूं। छे। और राकेश कुमार, तुमको एक बैंकिंग सिस्टम दिया हूं ना, और कुछ मैं दूं? राकेश,
Sir, you have given me that courier services.
कुरियर सर्विसेज, राकेश कुमार कुरियर,
FedEx.
फेडेक्स का। इन वर्ल्ड में दो इंपॉर्टेंट कुरियर सर्विस है वर्ल्ड में, एक फेडेक्स और एक ब्लू डार्ट ना। और कुछ है इससे बेहतर? और कुछ है? अरे बोलो कुछ, मुंह में क्या ताला लगाए हो ना क्या है? और क्या बड़ी ऑर्गेनाइजेशन क्या है?
Sir, first flight.
गधा का बड़ा बड़ा हमेशा रखो। बिग ऑर्गेनाइजेशन। और कोई है? कोई बता सकता है? मैं जो जानता हूं फेडेक्स एंड ब्लू डार्ट, राइट? अरे मेरा बात को तो कोई काटो। और इससे बड़ा ऑर्गेनाइजेशन कोई है ना? नहीं? ओके ओके, तो आप देखो राकेश।
सर।
Yes, sir.
हाँ, और कोई बड़ा है?
DHL सर।
है?
DHL भी एक है सर।
DHL, या DHL भी एक है। DHL शायद उसका बिजनेस उतना बड़ा नहीं है फेडेक्स के आगे, फेडेक्स एंड ब्लू डार्ट के आगे उतना बड़ा नहीं है। फेडेक्स इज नंबर वन।
यस सर,
फेडेक्स इज नंबर वन। मैं हमेशा बड़ा की एक एग्जांपल देता हूँ। फेडेक्स के सामने आई थिंक ब्लू डार्ट, DHL ये सब भी छोटा है। फेडेक्स इज नंबर वन आई थिंक। आप जरा देख लो राकेश, मेरे को बताना कौन सी
Yes, sir.
कंपनी इससे बड़ा है, ठीक है?
Okay.
मान लो कि तुम एक भेजोगे, एक कंट्री मान लो कि मेरी मुंह से आया, कहाँ? इस्टोनिया। इस्टोनिया किधर है बताओ तो? जा, हम तो निकले गधे राम। कहाँ है इस्टोनिया?
Sir, I don't remember.
आई डोंट नो, मैं तो जीके पढ़ता नहीं हूँ, मैं तो रास्ते में घूमता हूँ।
Sir, यूरोप में।
यूरोप में? यूरोप में कहाँ पर है तो बताओ। जा, इट्स वेरी डेवलप्ड कंट्री, वेरी डेवलप्ड, वेरी स्मॉल कंट्री, जो फिनलैंड के नीचे में है, एकदम छोटी सी कंट्री है। एनीवे, उसका कैपिटल क्या है देखो, ठीक है? वो बता नहीं पाया। बुदापेस्ट किसका कैपिटल है बताओ तो? बुदापेस्ट?
हंगरी, हंगरी।
अरे तुम क्यों बता रहे हो प्रतीक? राकेश को मैं पूछ रहा था। एनीवे, एक इस्टोनिया नहीं सुना है, हाँ, बुदापेस्ट के नाम नहीं राकेश सुना है क्या? तुम बचपन में कर रहा था है?
सर, नाम सुना है।
नाम सुना, बता नहीं पा रहे हो कोई? मैं पूछ रहा हूँ हंगे किसका कैपिटल है बुदापेस्ट, तुम मुंह में ताला। अच्छा, यहाँ से इस्टोनिया नहीं सुने, मान लो कि ये प्रतीक बता दिया। तुम हंगेरी का कैपिटल बुदापेस्ट एक पैकेट भेजोगे, मान लो कि तुम कहाँ तुम रहते हो? पटना में ना राकेश? ना कहाँ रहते हो?
सर, गया में सर।
गया में? हाँ, गया पटना बाजू में, ठीक है। अच्छा, तुम गया से भेजोगे बुदापेस्ट, और कैसे कैसे फेडेक्स लेके जाएगा, कितना जल्दी लेके जाएगा? एक एग्जाम्पल मैंने दिया। गया से तुम भेजोगे एक इधर सिडनी, गया से भेजोगे इधर साउथ अफ्रीका की कैपिटल क्या है? साउथ अफ्रीका? या सर ये सब हार्ड क्वेश्चन है।
सर केप टाउन।
केप टाउन राकेश बताना चाहिए ना। कुछ तो पढ़ाई करो, रास्ते में घूमते हो कुछ इंटरेस्ट नहीं आता है? इस्टोनिया किधर है, ये का कैपिटल किधर है साउथ अफ्रीका की? केप टाउन मान लो कि एक भेजोगे, तो कैसे गया से पैकेट कैसे कितना जल्दी जाके फेडेक्स की अपनी भी कुछ रहता है फ्लाइट, या तो कैसे दूसरे फ्लाइट अरेंज करके वो केप टाउन में सामान पहुंचाएगा। तो कैसे, हाउ डू दे प्लान फॉर दैट? हाउ अर्ली कुरियर वालों कैसे ही प्लानिंग करते हैं, कैसे ही ट्रैकिंग करते हैं, ट्रैकिंग का नंबर देके कैसे उसकी लोडिंग होती है, कैसे अनलोड होती है, कैसे डिलीवर होती है, कैसे बंदा का पास पहुंचता है जिसको तुम भेजना चाहोगे केप टाउन में, कैसे बुदापेस्ट में भेजना चाहोगे, कैसे वो मटेरियल पहुंचेगा और कितना चार्ज करेगा। चार्जिंग भी कुछ मीनिंगफुल होना चाहिए, अनवर्ड बेसिस। डीएचएल ज्यादा लेता है इसीलिए डीएचएल लोग जाते नहीं, तो तुम्हारा ज्यादा होना नहीं चाहिए। तो हाउ डू यू डू दैट? So all these things you fix up with some logic and everything. Logic means वही guard condition आ गया LTSA की, with a particular software. with a particular software. कुरियर में मान लो कि ये जो वॉलमार्ट की प्रतीक की दुकान है न्यूयॉर्क में, पहले यहाँ से कोरिया से मान लो कि कुछ लैपटॉप जाएगी कोरिया से, तुम्हारी फेडेक्स के थ्रू में भेजेगा वॉलमार्ट एट न्यूयॉर्क। कैसे, हाउ यू विल कीप टेक दोज लैपटॉप या आईपैड, एप्पल का आईपैड वहां बनती है कोरिया में, कोरिया से कैसे वो ट्रांसपोर्ट होगा? अभी जो प्रेसिडेंट बने बिडेन बाबू को आईपैड विद इन 24 आवर्स उनके स्टाफ के लिए। तो बिडेन बाबू को तुमको खुश करना है, कितना जल्दी तुम कोरिया से सामान लेके पहुंचा सकोगे। हाउ फ्रॉम द फैक्ट्री इन कोरिया टू न्यूयॉर्क और वॉशिंगटन, हाउ अर्ली यू कैन मेक प्लान टू मेक द आइटम अवेलेबल। ये है कुरियर कंपनी की खासियत। तुम प्लान कर पाओगे, हाउ यू विल प्लान and then send the iPad from Korea to Washington DC. Okay, मैंने जो बोलना था बोल दिया। तुम लोग थोड़ा पढ़ो, पढ़ने के बाद मेरे से अगर तुम बात करना चाहोगे तुम SRS लिखो धीरे धीरे, और परसों अगर किसी को भी चाहिए सब तुम लोग बात करो। अगर तुमको कोई मदद चाहिए आई एम देयर। और एक किसको देने के लिए चाहता था, वो शिवम डालमिया वो नहीं है। इस तरह का आदत तो सोच खराब है, मैं दिया नहीं एंड ही लेफ्ट। ओके, इंगोले है ना, तुम चला गया। इंगोले हैज लेफ्ट। एनीवे आई हैव टेकन द अटेंडेंस। ओके ठीक है। ओके बॉयज, यू हैव गॉट क्लास इन द आफ्टरनून।
यस सर।
कितना बजे
1:15।
वो जाओ खाना खा लो, जा। ओके, मैं ज्यादा ही टाइम ले लिया, ठीक है। इफ एट ऑल यू नीड यू सेंड मी ए मेल। 4:15 सैटरडे। ओके, बाय स्टूडेंट्स, बाय।